Tonight, in the quietest part of the sky, something is turning the wrong way slowly, softly, as if it remembers a path no one else has ever known. You're listening to Whispers of the Universe, and if you're kind enough to leave even the smallest trace of support for this quiet place, it helps this fragile corner of the night keep breathing. For as long as we have watched the heavens, stars have obeyed a simple rule. They spin in the same direction as the clouds of gas that gave birth to them. From a cold molecular mist, a faint swirl grows, gravity gathers it inward, and the young star keeps the momentum of that ancient twist. It is the first lesson of stellar formation, the first rhythm written into a star's life. No star escapes it, or so we believed. Yet somewhere beyond the spiral arms, where darkness drifts without interruption, a single star is quietly breaking that rule. It is rotating backward, not violently, not chaotically, just backward, as if the universe taught it a different song. The discovery began on a night that held no special meaning. A small team was simply measuring rotational velocities of young stars' routine work meant to refine models of planet formation. Nothing unusual, nothing dramatic, and then a single spectrum arrived, with its red side slightly too blue, its blue side slightly too red. It was like hearing one instrument in an orchestra breathe half a beat out of time. No one took it seriously at first. They assumed a sensor drift, a calibration error, a bit of stray light sneaking across the detector slit. It happens. It always happens. But the second measurement said the same thing. And the third, and the cross-check against Gaia's catalog confirmed it without hesitation. The star was spinning opposite the system around it. In that moment, the room changed. Not loudly, not with celebration, but with the quiet heaviness of people realizing they are touching the edge of something, unnamed. It felt like walking through a forest at night and hearing a call that belongs to no creature in any known book. They zoomed in on the star through every layer of data, its temperature, its luminosity, its magnetic activity. On the surface, it was ordinary. A mid-aged star, just slightly hotter than our sun, neither too big nor too small. No massive planets tugging at it. No scorched debris disk wrapped around it. Nothing in its outer appearance hinted at any kind of cosmic trauma, but something deeper was wrong. Not in a dramatic way, just a faint asymmetry in the spectral lines, as if the star's light carried a memory it could not hide completely, like a forgotten sentence written in the margin of a book that had been rewritten too many times. And so the first question rose, quiet as a breath. If a star learns its spin from the cloud that formed it, who taught this one to turn the other way? The question was gentle, but it struck with the weight of a stone dropped into deep water. Ripples spread, formations were reconsidered, models were rechecked. The certainty of every star spins with its birth cloud suddenly felt less like a law and more like a suggestion. And somewhere in that uncertainty, the team began to sense something else, an intuition, faint as a whisper. What if the star is carrying a scar? What if it remembers something about the moment it formed? Something that bent its path before it ever learned to shine? They didn't say that out loud, not yet. But the thought lived in the quiet space between their observations. What unsettled them even more was how calm the backward rotation looked. A violent collision would leave turbulence, heat, a spinning debris field. A tidal flip from a massive neighbor would create measurable distortions. But this star's rotation was steady, almost peaceful. It was turning backward the way a clock might, not because someone forced it, but because it found a different rhythm long ago and never returned. One astronomer compared it to watching a pendulum that insists on swinging against the direction of gravity. Another said it felt like seeing an old wound, not the event itself, but the faint, healed shape of it. The team sent their results to an external data center, expecting rejection. Instead, the verification came back with a clarity that made them sit in silence. Everything around the star was rotating correctly. Gas, dust, smaller bodies, all following the proper direction. Only the star, at the center of everything, turned the opposite way. Like a single backward swirl in a sea of forward motion, a lone stroke of paint flowing against the shape of the canvas. As they collected higher resolution data, a second mystery appeared, not in the speed of the rotation, but in the polarization of the starlight itself. A tiny, repeating pattern, barely visible, barely strong enough to measure, pulsed in the beam. Not a signal, not noise, but a rhythm, a faint echo in the light, repeating so slowly that it felt like the ghost of something that once happened long before the star began to age. A slow turn in the dark. No one wanted to say it, but they all felt it. The star wasn't merely spinning backward, it might be remembering something. And so the thesis formed itself quietly, in the room, without ceremony, without anyone needing to write it down. No object in the universe turns against its own beginning unless it carries a memory or a fracture from the moment it was made. They didn't know yet what that memory was. They didn't know what force could have twisted a star's momentum without tearing it apart. But the star's backward spin was not random. It was deliberate in its calmness, ancient in its steadiness, and unsettling in its refusal to match the world around it. As the night deepened, the team stayed longer than planned. They watched the data reshape itself, watched the curves tighten and the uncertainties shrink. And with each refinement, the backward rotation became more undeniable, more precise, more impossibly smooth. It turned like a dancer retracing an old step, like a river bending uphill, like a memory turning over inside a mind that has never forgotten. And somewhere far beyond what they could measure, the star kept moving, kept twisting itself through the dark, its lone defiance, a quiet mark on the canvas of the galaxy, a slow turn in the dark, a secret written in motion rather than light. And as one of them whispered before the lights were dimmed for the night, perhaps to break the silence, perhaps because she felt the universe was listening, whatever happened to it didn't end. It's still turning through that moment. The others didn't answer. They didn't need to. The backward spin answered for them, carrying its quiet contradiction into the deep hours, a direction no star should choose, and yet this one did. And so the long search began, quietly at first, like a ripple spreading across water that still remembers the stone that touched it. They returned the next night, and the night after, carrying with them the weight of a question that had no rightful place in the known architecture of physics. The star's backward spin wasn't a coincidence. It wasn't an error. It wasn't even an anomaly, not in the casual sense of the word. It was a contradiction woven into motion, precise, consistent, unwavering. Something had happened to it, something long before telescopes, long before planets, long before anyone could have given it a name. Their first task was simple: observe again and again, until nothing remained except certainty. Astronomy often begins like that, a kind of devotion, a quiet act of staring until patterns reveal themselves. So they pointed the instruments at the star for hours, letting photons pour across the detectors like grains of sand falling into a measuring bowl. Every few minutes, a monitor refreshed, the curves sharpening, the uncertainties shrinking, and with every refinement, the backward rotation grew even clearer. It was almost eerie how smooth the reversal was. A star tossed by violence would show scars, thermal fractures, uneven convection patterns, chaotic surface flows. But this one rotated with the elegance of a wheel that had always chosen its own direction. No turbulence, no leftover chaos, no trace of a cosmic shove or tear. Like a dancer not thrown off balance, but simply turning toward a memory. One of the researchers, an older man who had spent decades charting star spots, leaned back in his chair after a long stretch of silence. "If it was hit," he murmured, "you'd see the bruises. Stars wear their injuries for millions of years, but this star wore nothing. No bruise, no heat scar, no asymmetry that explained a forced reversal, which meant one, whatever changed its momentum wasn't violence. Or if it was, the violence was of a kind no one knew how to recognize. They ran magnetometric analysis next. Stars, after all, are knots of magnetic tension, threads of plasma woven through fields, strong enough to tear worlds apart. If the spin had been disrupted, the magnetic field would show it. The star's field was steady, structured, elegant. Its loops rose and fell like slow breaths, its polarity cycling at a rhythm whisper-thin but measurable. And buried within that rhythm was something so subtle it took hours of averaging to reveal. A delay in the magnetic crest, repeating over and over, always the same length of time behind where it should have been. A lag, a soft drag, as if the field were following something deeper inside the star that rotated at a slightly different pace. A slow turn in the dark. They watched the pattern print across the monitors like a heartbeat from a creature they could not see. It pulsed with the confidence of something old, older than the star's surface, older than the visible layers, older perhaps than the current orientation of the star itself. A buried rhythm, echoing from a time before the reversal. And with that came another question, one that settled heavily in the center of the room. What if the surface isn't the part that changed? Because stars are layered. Their surfaces rotate at different speeds than their cores. Their cores hold memories the outer layers never see. If something twisted the star's interior before it finished forming, the surface might simply be obeying the command of a deeper rotation, one that had been reversed long before the star became whole. It was a possibility, but a terrifying one. If the reversal came from the core, it meant the event that caused it happened when the star was only a collapsing cloud, fragile, diffuse, vulnerable to forces that could pass unnoticed through dust and gravity alike. Something could have touched it before it was even a star. They searched the surrounding region next. If the star had been influenced by a massive neighbor, say a rogue stellar remnant or a passing black hole, there would be traces, uneven dust distribution, stray heating patterns, gravitational shears. But the region was pristine, smooth, too smooth, not empty but undisturbed, the way untouched snow smooths itself over footprints until they vanish. No massive object had passed through. No tidal force had warped it. No collision had left behind a trail. It was as if the whole system had grown up in silence. And yet, one detail refused to sit quietly: the dust ring around the star. It was faint, fragile, almost ghost-like. It held a peculiar asymmetry, one half slightly more diffuse than the other. Not torn, not shredded, but thinned, like fabric that had once been pulled taut and then released. A memory of tension. The team mapped the dust distribution with a resolution so fine it bordered on obsessive. They traced the faint arcs, the subtle bends, the slight offset in angular momentum, and gradually, a whisper of an idea began to form. The dust ring wasn't guiding the star. The star had once guided the ring, and something had reversed that guidance. The star had not been forced into a new rotation. It had been untethered from the rotation of its birth cloud. And that was even stranger, because momentum is not something easily broken. To reverse it gently without tearing anything would require a subtlety of force far beyond any known astrophysical interaction. Something nudged it. Something leaned on it with the softness of a shadow. Something adjusted its path, not the way a hammer strikes metal, but the way a hand smooths cloth. What kind of event leaves no wound? Someone whispered, and yet changes the direction of a star. No one answered, but the star kept turning. Each rotation a reminder that the laws they trusted had exceptions written in motions older than memory. They expanded the search radius, looked for remnants, traced stellar motions backward across millions of years, checked catalogs for anything at all that might have passed nearby. A neutron star on a runaway trajectory, a wandering brown dwarf, A compact object too small to glow but large enough to tug. Nothing. It was like combing the ocean for the wake of a ship that might never have existed. So they turned inward toward the data itself. If the star carried a memory, it would be hidden in its spectrum. Spectra are fingerprints, stories pressed into light. They reveal temperature, composition, motion, age, and sometimes, when the universe cooperates, they reveal trauma. The team stretched the spectrum to its limits, looking for inconsistencies in helium lines, carbon absorption edges, metallic ratios, and there, on the edge of detectability, they found it, a slightly elevated abundance of helium at the surface. Not enough to classify it unusually, but enough to hint that helium normally buried deeper inside had once been pulled upward, like something inside the star had surged forward, then settled again. Not violent, not explosive, but disruptive in a way that left only the faintest residue, a ghost of uplift. Theories rushed in, colliding softly like drifting icebergs. A magnetic inversion, a partial collapse, a fragment of a proto-stellar jet folding back into the star? But each model failed for the same reason. None could reverse the star's rotation without tearing the outer layers or leaving a chaotic magnetic signature. And yet the star was calm, quiet, balanced, turning backward with serene precision. It was then, deep in the quiet hours, that someone made a comparison no one wanted to make. It's as if the star rewrote its own beginning. The room stilled, because that was not a scientific suggestion. It was a poetic one. But sometimes, in the very center of science, poetry is the only bridge toward truth. If the star carried a memory, that memory might be older than its rotation, older than its formation, older than the dust that shaped it. A seed of momentum planted before the star was whole. Something had reached it when it was still forming and turned the seed. A slow turn in the dark, planted deep, waiting for the star to become solid enough to show it. And so they looked at the data again, not for explanations, but for hints. And at the edges of the cloud remnants surrounding the star, they saw a faint curvature, not a spiral, not a trail, but a gentle, almost imperceptible bend, as if a stream of something not matter, not radiation, not wind, had once passed through, nudging the forming star with the softness of a memory brushing skin. No force, they understood, behaved that way. No known interaction touched a star that delicately. No event in the catalogs resembled this. But the bend was real. The reversal was real. The memory was real. Something had happened. Something still echoed. Something older than the rotation now carried in silence. And as dawn began to wash the sky in pale blue, the star completed another backward turn. Steady, patient, almost contemplative. The sedate defiance of an object that refuses to forget. And in that moment, none of them could shake the feeling that they were not studying a star, but listening to one. They returned to the data with a kind of quiet persistence that only grows when a mystery refuses to move aside. The room felt different now, not heavier, not lighter, but stretched, as if the space between each person held the echo of something unspoken. They were no longer just observing a star, they were circling it, listening for anything it might reveal if given enough silence. One of the researchers projected a high-resolution reconstruction of the cloud fragment that once surrounded the star. The image blurred softly at the edges, like a memory trying to form. Threads of dust curved across the screen, delicate and uneven, not spiraling the way a typical protostellar cloud should. Something had touched this formation, not torn it, not carved it, just shifted it. A gentle bend where no gentle explanation existed. They zoomed in, pixel by pixel, stripping away noise until the image became little more than a whisper of density variations. And in that whisper, they saw it again. A faint asymmetry, small enough to overlook but too consistent to dismiss. A distortion like the residue of a passing tide. Gravity alone couldn't do it. Plasma winds wouldn't curve that precisely. and shock fronts leave edges, not contours. This was softer, a brushstroke instead of an impact. What moves through a cloud like that? Someone asked, barely above a murmur. No answer came. Instead, they examined the dust velocities, tiny shifts in residual motion, the leftover momentum of particles still drifting after millions of years. Dust remembers. Even when stars forget, dust clings to direction. And the dust around this particular star carried a faint clockwise preference, even though the star itself now turned counterclockwise. Like a child grown old, but still marked by the way its cradle once rocked. If the dust carried the original direction and the star carried the reversed one, then the moment of separation, the moment of forgetting, must lie somewhere in between. They ran simulations, countless ones, clouds collapsing, jets firing, fields twisting, nearby bodies passing, tiny gravitational eddies stirring the edges. Each time, the dust kept its birth motion. Each time, the star kept its birth motion. Nothing reversed, only the star. Nothing except events violent enough to leave scars, and this star had none. Eventually, room dimmed as someone shut off the overhead lights, leaving only the glow of screens. It made the data feel closer, as if the star itself were leaning into the dark room, sharing the faintest parts of its history. The simulations failed quietly, one after another, until a younger researcher frowned at a slow-moving graph on her screen. "That's odd," she whispered. "There's a phase lag in the internal shear." She highlighted it. A tiny delay between the rotation rates of the star's layers. Not unusual by itself, stars often rotate differentially, their surfaces slipping over deeper layers like sliding plates. But the pattern here was too clean, too synchronized, too deliberate. A rhythm, a delayed echo of an earlier rotation, preserved inside, like a song played backward through the layers. What if something reversed the inner rotation first? She asked. Not the outside, the core. Another silence, a heavier one, because reversing a star's surface is improbable. But reversing its core without shattering it is impossible. Cores are dense, rigid, in a way nothing human-made can mimic. They cling to their rotation with the stubbornness of memory. If a force acted only on the core, and only early enough when the star was still gathering mass, then perhaps the outer layers would form around a backward-turning heart. A slow turn in the dark, hidden under the surface, until the star grew large enough to reveal it. But, another voice said softly, what force reverses a core while leaving the cloud intact? No force, they knew. They checked the surrounding sky again. Wide field scans, deep surveys, motion maps across millions of years. They looked not for objects, but for absences regions, where something once was but no longer remained. A missing star, a runaway companion, a traveling remnant that might have brushed too close. In the maps, they found a faint corridor, a path of slightly altered stellar motions, stretching across many light years, subtle, nearly invisible, unless you looked for it with the right kind of attention. Stars along that corridor drifted with a shared tilt to their velocity vectors, as if something had moved past them long ago, tugging them gently in alignment. A visitor, not massive enough to tear, not bright enough to see, not quick enough to leave chaos, but present, real, influential. What if, someone whispered, this star wasn't alone when it formed? The idea lingered, a companion that no longer existed, or no longer glowed, or moved on, carrying whatever mass and whatever influence it once had. They traced the corridor backward, running the stellar motions in reverse, like rewinding a cosmic spill across a dark floor. The corridor converged into a point where, millions of years ago, something might have lingered. Not a star, not a planet, something smaller, denser, dimmer, a remnant, perhaps a stellar corpse cooling in silence, a white dwarf stripped to its ember, or something even stranger, something that doesn't shine at all. A compact object that might have drifted into the forming cloud passed through it and left without settling. A brush, not an encounter. A whisper, not a collision. If such an object carried enough gravitational structure, its passing could nudge the rotation vector of the densest part of the newborn star, its core, without disturbing the outer dust. A shift so subtle that the cloud continued collapsing like normal, except for the seed of reversed rotation planted at the center, a seed the star would carry forever. The team fell quiet again, letting the idea hover. It wasn't proof, not yet, but it was the first hypothesis that didn't break itself under scrutiny. And then came the most delicate part of the analysis, searching for leftover motion in the star's light itself. Light doesn't just reveal composition, it reveals history. Using polarized spectroscopy, they filtered the star's light until only a thin strand remained, the rotationally tangled imprint of magnetic fields threading through its layers. They stretched that strand across a temporal axis, smoothing it, amplifying it, removing noise until the pattern became visible. Not a perfect curve, not a smooth wave, but a spiral, gently twisted, a spiral inside the light. Spiral patterns emerge when something rotates unevenly over time, when outer layers are taught one rhythm and inner layers another. The signature was ancient, fragile, barely surviving the ages. But it was there, a mismatch between the original rotation and the reversed rotation, a layered memory, a slow turn in the dark, echoing through the decades of light that traveled to reach them. What if we're not looking at a reversal? Someone said quietly, but at two directions, layered inside one star? The thought chilled them. A star rotating one way at birth, then before it finished forming its core, nudged into a different direction. Not enough to tear, not enough to break, just enough to rewrite the guiding axis. A fracture in its beginning, a memory held in motion, a secret stitched into light. They played the reconstructed rotation back in time, accelerating it until the mismatched layers aligned, until the star spun smoothly in the direction the cloud intended. And then, frame by frame, they watched the inner rotation tilt, just a few degrees, then more, then fully reversed. Not a flip, not a jolt, a tilt, like a planet slowly changing its seasons. A reorientation so calm, it felt intentional, as if something had leaned into the forming star, whispered a different direction into its heart, then left without waiting for the outcome. What kind of force does that? Someone asked. No one had an answer, but the question deepened the mystery, turning it from a puzzle into something closer to a story, one written long before humans learned to look up. And as they prepared their next series of measurements, the star rotated once more, steady as breath, patient as dusk, settling over a silent field, a quiet defiance, a lingering memory, a motion that should not exist, and yet persists, a slow turn in the dark. They began the next phase of their investigation by stepping further outward, away from the star itself, away from the cloud that once cradled it, and into the broader weave of space the star called home. The surrounding region was unremarkable at first glance, a sparse field of faint suns wrapped in gentle arcs of dust. But when mysteries refuse to rest, even the quietest places become suspect. The team overlaid maps from multiple surveys, deep field infrared, millimeter wave dust scans, sub-millimeter polarization grids, layer upon layer of silent history. And as each map settled onto the others, small deviations rose like faint ripples under starlight. The region had once been disturbed, not violently, not chaotically, but nudged subtly by something that moved through with the calm persistence of a drifting mass. A narrow corridor of irregular velocities stretched across the sky, the same faint alignment they'd noticed before, but now, with all the data combined, the corridor resembled a brushstroke, thick at one end, thinning as it extended, dispersing into nothing. A footprint that did not belong to a star, bound by the galaxy's rotation, a footprint of something wandering. They traced the thickest part of the corridor, the region where the disturbance was strongest. There, the dust density shifted in a fragile curve, as if shaped by a passing tide. No sharp edges, no torn filaments, just a subtle bending of matter, the way water folds around a stone. It didn't collide, someone whispered. It simply passed through, and passing through was somehow more unsettling. A collision is loud. A tidal event leaves scars, but a close drift, could alter a forming star's core without leaving anything anyone would know how to name. To explore the possibility, they modeled what might happen if a dense, compact object, something with the mass of a collapsed star, but without the brightness, wandered slowly through a collapsing cloud, not slicing it apart, not consuming it, just leaning, with a gravity so condensed it could nudge the core without disturbing the outskirts. The simulations returned images that made the room fall completely silent. A forming protostar, a fragile sphere of plasma and dust, swirling as all clouds do. Then a compact mass eased past a ghost, with weight tilting the center of rotation by degrees so small, the surrounding matter hardly noticed. The cloud continued collapsing normally, folding into itself, building heat, forming layers, but the heart of the star, the densest part, carried the altered axis, and when the outer layers formed, they aligned with the star's original rotation, while the core kept the new one. Slowly, inevitably, the core's reversed momentum asserted itself softly, pulling the upper layers into alignment with its counterflowing spin. A core seated with another direction, a quiet inversion hidden for millions of years until the surface could no longer mask the internal truth. A slow turn in the dark. The youngest researcher in the room whispered, "It wouldn't even need to touch the star, just passing close enough. The core is so light at that stage." Another scientist, older, leaned forward. But what kind of compact object moves that slowly? Most remnants race across the galaxy. No one knew. But the simulations contained something else, an unexpected pattern. In every successful reversal, the compact object traveled not in a straight path, but in a gently curved arc, almost as if it were responding to another gravitational field, or perhaps its own motion was constrained by something unseen. As they examined the curved path, an idea strange and unnerving began to surface, one that none of them wanted to voice, but all of them felt. A compact remnant didn't have to be alone. Some remnants orbit other things, and some things they orbit are invisible. There are models, someone began carefully, of ultra-dark pair systems, objects bound to nothing we can see. Another silence, not the thoughtful kind, the fearful kind. Because if a dark pair, two objects, one visible only through mass, the other nearly absent, drifted through the cloud, it could create a gravitational contour exactly like the one they found. A contour gentle enough to nudge a forming core. A contour so faint no telescope could trace it. A visitor with no light. A traveler bound not by its own glow, but by something darker. What if it was never one object? The researcher continued slowly. What if it was a system, moving like a shadow with a shadow? The room shifted again, not visibly, not physically, but in mood. The star's backward rotation suddenly felt less like an anomaly and more like a message left behind by something passing through, a signature event imprinted only in motion. They turned back to the star, studying it now with heightened awareness, as though it might reveal what it had encountered all those millions of years ago. The magnetic lag, the layered rotation, the dust asymmetry. Every piece felt like part of a puzzle whose edges they were only beginning to find. And then one of them noticed something peculiar. When they stretched the polarization data even further, long past the point where noise should have drowned out, meaning the lag in the magnetic field formed a repeating slope, almost like a slow, spiraling descent. Not chaotic, not random, A pattern. A pattern shaped by two motions, not one. A surface rotation following the core, and a core following something else. What would the core follow? The younger scientist murmured. The answer came softly. Another rotation, a deeper one, older than the core. A rotational imprint left by the passing object. A gravitational fingerprint embedded in the collapsing gas. Stars do not normally inherit such fingerprints. They inherit the momentum of their cloud, nothing more. But if the cloud encountered a structured gravitational field, one shaped by another rotating object, then the seed of rotation could be altered, not replaced, augmented, layered. The star might be carrying the echo of another object's spin, a slow turn in the dark that was not its own. They modeled it, fed the numbers into the simulation, ran the timeline backward to when the cloud was thin and the star barely an ember. They introduced a rotating gravitational distortion, weak, diffuse, but structured, passing through the cloud. The core responded immediately. The outer cloud responded hardly at all. And when the cloud collapsed into a star, the core retained the distortion spin. The surface gained its normal rotation. The two motions fought quietly over millions of years, and eventually, the core won. The simulation ended with the entire star spinning backward, stable and calm. The room stayed still. Then one voice broke the quiet. So the star didn't choose, it inherited. Another added, it inherited a rotation from something we never saw. The thought lingered. If that were true, if a star could inherit the motion of a passing invisible system, then the reversal was not an anomaly. It was evidence of something else. Something that moved through the galaxy without light, without heat, without a name. Something that shaped matter only by passing close enough to brush its memory across. The newborn. A faint gravity born of something the universe does not easily reveal. The star rotated once more, on the screen backward, serene, unwavering, and the researchers felt it again, not as science, not as data, but as presence, a memory, not the star's memory, a memory given to it, a slow turn in the dark, not its own, but carried faithfully, quietly, across millions of years. Outside, the night deepened, and the star, far away and utterly silent, kept spinning the way it was taught by something that had no light to give. They focused next on the corridor itself, the path of disrupted motions stretching across the neighboring sky. It was faint, almost fragile, yet unmistakably real. A distortion so soft, it could have been mistaken for noise, if not for its consistency across independent datasets. Space does not lie. Matter does not drift without reason. Every movement in the cosmos has a lineage. The corridor was that lineage. It wasn't straight. It wasn't chaotic. It curved wide, graceful, shallow, as if following the contour of an invisible structure, like the wake of a slow-moving ship in a sea whose surface remembers every passing shape. When they mapped the curvature, the result resembled the trace of an orbit. Except the orbit was incomplete, as if the object had drifted too far to finish its loop, or had never meant to return. Something massive enough to leave a directional imprint had traveled here long ago, but nothing in the region now reflected its presence. Objects with mass do not vanish, but objects without light can hide. The team then examined velocity dispersions, tiny shifts in nearby stars' motions, like dust motes caught in a breeze. The dispersions aligned with the corridor's arc, not tightly, not clearly, but subtly enough to show a shared influence. Something had passed through this region, gently tugging on the fabric of local motions, adjusting trajectories by the smallest measurable degrees. A brushing mass, not a collision, not a companion, a traveler. When they simulated the traveler's passage, they expected disruption, but the model returned something else, a gravitational field shaped not like a single object, but like a system. Two centers of mass moving together, one dominating, the other almost negligible, a binary. But a binary of what? The dominant component, dense, heavy, could easily be a cooled stellar remnant, a white dwarf perhaps, or a tiny neutron star stripped to essential mass. But the secondary component, its influence was odd, too light to be stellar, too structured to be debris, too faint to be dismissed. What if the secondary is not matter as we understand it? Someone murmured. They all heard it. No one disagreed. The corridor's curvature supported it. The dust displacement supported it. Even the star's layered memory supported it. A two-body system in which one body was nearly invisible, truly invisible, not dim, not cold, but unresponsive to light entirely. A dark partner. Not dark matter in the broad cosmological sense, the diffuse halo that binds galaxies together, but something more concentrated, more local, more itinerant. A compact dark object bound to a faint remnant, a shadow orbiting a fading ember. They ran more simulations, refining the gravitational signature until the imprint matched the corridor's shape. The solution converged slowly, reluctantly, like a truth resisting its own revelation, but eventually, the numbers settled. The companion exerted gravity, but not symmetrically. Its influence fluctuated, as if shaped by a structure or rotation of its own. Gravity that pulsed. No ordinary object pulses gravity, but some theoretical ones do. Exotic matter distributions. Dark, compact halos. Particles that cluster without interacting with light. The team felt the shift in the room. They were stepping into territory where observation blurs into speculation, and speculation brushes the edge of theory never confirmed. They zoomed back in on the star, because if such an object had drifted near it during formation, the star's memory should contain more clues. They examined rotational jitter-minute variations in the timing of the star's spin, deviations so small they seemed at first like instrumental static. But static is random. These were not. They formed a repeating pattern, a faint modulation of rotation period, a gravitational echo, a memory of a companion's passing rhythm. It wasn't a rotation the star created, it was a rotation the star received. What do we call a memory inscribed by gravity? One scientist asked. The question hung in the dim glow of monitors. Gravity writes its stories differently. It leaves curves, not scars. Tilts, not fractures. Rhythms, not marks. And here, the star's spin carried the rhythm of something that had once moved past it, a rhythm not matched to physics as they knew it. The modulation was too clean, too periodic, almost like the orbital period of a binary system, but faint and decaying, as if fading across time until only the most stubborn part remained. A slow turn in the dark, repeating like an echo that refuses to die. The scientists deepened the analysis, examining whether the modulation aligned with the corridor's curvature. They overlaid the two datasets. One described a gravitational influence in space. The other described a gravitational influence in time. If the same object had caused both, the patterns would overlap. They did. Not perfectly, not sharply, but enough that the room fell silent the moment the graphs aligned, their peaks breathing in the same slow rhythm. A traveler had passed, a binary with one faint body and one invisible one. It had drifted through the forming cloud, bending the core's seed rotation like a finger tracing a slow spiral into soft dust. When they computed how long ago this must have happened, the answer made something inside them shift. The reversal occurred not millions of years ago, but tens of millions. The traveler was ancient and long gone, yet its influence lived on in the star, a gravitational echo so soft it left everything perfectly intact except the direction of the star's spin. One of the team leaned back, eyes distant. If something like that passed through this region once, could it pass through others? Another replied, stars would bear the evidence if we know what to look for. They all thought the same thing then, though nobody spoke it. This might not be the only backward star, but this was the one they noticed first. Because its memory was clearer, its rotation more stable, its echo more preserved. They returned to the corridor map, examining not the past but the future. Where would the traveler be now, millions of years after its passing? The arc implied a slow drift toward a sparse region of the galaxy, where few stars exist to reveal its presence. It could be anywhere. It could be nowhere. It could be passing through another cloud right now, carving another faint bend. What if the dark companion isn't rare? Someone whispered. A chilling possibility. The team reviewed archival data from stars in a wide radius, searching for similar reversed spins, unusual magnetic lags, mismatched layers. They found hints, one here, another there. None as clear as this star, but none explainable by ordinary physics. Subtle reversals, slightly off-axis rotations, spectral tensions like faint scars. The implication deepened. Perhaps backward-turning stars were not aberrations. Perhaps they were signatures, the footprints of travelers, with partners made of something the universe rarely lets itself show. Outside, the world slept. Inside, the star's profile glowed on the monitors, steady, patient, carrying its borrowed rotation through the night. A memory not its own, a rhythm left behind, a motion seeded by something unseen, a slow turn in the dark, endlessly repeating. And the team finally understood. To uncover what touched this star, they would have to search not for light, but for the absence of it. They turned their attention back to the dust, the faint, aging ring that circled the star like the memory of a memory. Dust is honest. It drifts. It settles. It resists forgetting. Where gas flows and plasma churns, dust lingers long after the event has passed, preserving its shape the way the grooves of a record hold the imprint of sound. And the dust around this star held an imprint. The asymmetry was clear now. One half of the ring stretched thinner than the other, like fabric pulled gently. Once, a very long time ago. It did not look torn or disturbed. It looked eased, the way clay shifts under a slow, deliberate hand. When they overlaid the curvature of the dust ring onto the reconstructed corridor, the alignment was undeniable. The thinning pointed directly along the traveler's path, almost like a faint bow wave trailing behind a moving mass that never lingered long enough to leave heat or shock. The star had formed in the aftermath of something drifting past, but the dust told a deeper story. If the ring had once been a forming disk, a swirling sheet of material collapsing around the star, something had parted it. Not shattered, not blown away, parted, like water around a slow-moving object. And where the disk had parted, the core's forming rotation might have been pulled, nudged, leaned upon. They sharpened the dust model, refining it with higher resolution millimeter wave data. The thinning wasn't just a section. It curved inward like a faint trough, a shallow depression carved into the density of matter. Not chaotic, not random, a consistent bending, as though something had once passed through the disk itself and slipped away into darkness. What if the disk wasn't just disturbed? One scientist suggested. What if it was split? The room grew very quiet. They ran hydrodynamic simulations of a forming disk, encountering a wandering compact object. Most simulations resulted in disasters, disks shredded, matter thrown into space, protostars destabilized. But when they adjusted the traveler's speed to something incredibly slow, so slow that it moved through the disk like a moon drifting through thick fog, the results changed. The disk parted smoothly. The protostar wobbled, but did not break. And the inner seed of rotation shifted direction by a delicate margin. The disk then closed behind the traveler, rebalancing itself, but retaining the faint thinning where matter had flowed aside, exactly what they saw in the dust today. What startled them further wasn't the split, but the shape of the split. The trough had a slight curl, like a curved passage, not straight, not uniform. That curvature matched the corridor's arc. The traveler had not simply passed near the forming star. It had passed through its disk. A presence with mass, but not with light. A weight, but no heat. A form, but no signature. Only gravity. The researchers zoomed in further on the inner dust. The closer to the star they looked, the more intricate the distortions became. The trough did not simply widen, it bifurcated. Two faint branches splitting off, like the arms of a delicate spiral. Two influences, not one. A binary again. A remnant and its dark companion drifting through the forming system, carving a pair of soft channels in the collapsing matter. If the remnant carried the larger gravitational pull, it would carve the deeper trough. The dark companion, though weaker, would leave a second, faint indentation, and there they were. Two trails, twin signatures, subtle but present. A pair, moving in unison through the cloud, like shadows drifting across fog. It matched the corridor. It matched the core rotation. It matched the magnetic lag. Everything pointed toward the same impossible event. What we're seeing, someone whispered, is the fossilized wake of a binary that shouldn't exist. Another answered softly, not shouldn't, just one we were never meant to detect. As they studied the bifurcation, they realized something else. The two channels twisted slightly relative to each other, as if the pair was orbiting while moving, a slow spiral superimposed on a slow drift. One channel curved outward, the other curved inward. A slow, graceful double helix motion. Gravity in motion, inscribing a memory inside a forming star. The team examined how such motion might influence the gas flow. When they modeled it, the result was beautiful in its simplicity. The inner region of the protostar was twisted gently into about counter-rotation, while the outer cloud remained faithful to its original direction. Over millions of years, the contradiction resolved itself the only way it could, by allowing the core's imprint to assert dominance, flipping the star's rotation into the reverse. Not violently, not abruptly, but gradually, patiently, like a tide shifting direction in the dark. That would explain the layered memory, one scientist said. Why the magnetic lag repeats at that decayed interval. They checked the magnetic lag again, and this time, something new emerged. The lag wasn't constant. It decayed exponentially, as if the deeper rotation had been stronger in the past, then faded over time. A fading memory, but still a memory. They overlaid the decay curve onto the time estimate of the traveler's passage. The curves matched, not perfectly, but closely enough that the room felt suddenly smaller. The memory was fading at the exact rate expected of a rotational imprint seeded during formation. It's like reading the echo of an echo, the older scientist murmured. A memory of motion left behind by an object that never meant to touch anything, but it did touch. Not physically, not with force, with gravity, soft and intimate as a fingertip brushing dust. One of the researchers calculated the energy required for the split. The numbers were small, shockingly small. The traveler did not need to be massive. It simply needed the right kind of gravity. Not strong, not forceful, but structured. A shaped gravity. A field that rotated slightly. A field that pulsed. What kind of object carries a rotating gravitational field? Someone asked. The answer was not comforting. Objects bound to dark companions. Systems where mass is not uniform. Pairs where one body distorts space-time differently than luminous matter does. A dark binary is not just invisible, it is asymmetric. The passing of such an object through a forming cloud wouldn't tear or crush. It would, instead, twist, bend, suggest, nudge, a memory-making gravity. The team leaned closer as the final model rendered. A visualization of the star-forming cloud, languid and glowing, with a binary pair moving through. One body glowed faintly, the remnant. The other was invisible, but its influence was drawn as a soft, rippling distortion. The cloud parted around them, flowing aside, merging again. The protostar's core tilted, the outer layers shrugged it off, and the star, once formed, carried the contradiction inside. The simulation ended with the star spinning backward, softly, steadily, a slow turn in the dark. By now, the researchers had stopped speaking. The discovery was no longer a question of data, it was a question of implications. If a dark binary had passed through this cloud, then others might wander through other clouds across the galaxy, and stars silent, patient, luminous would carry their signatures. They returned to the dust image one more time, looked at the bifurcation, the twin trails, the curved parting of the forming disk, and one of them whispered the thought they had all avoided. We're not looking at an anomaly, we're looking at a footprint left by travelers that do not shine. A footprint left in motion, not matter. A footprint preserved only because the star was young enough to remember. Outside, the distant star continued its backward rotation, not rebellious, not strange, but faithful to the moment something unseen brushed through its birth. A memory etched not in light, but in turning. A slow turn in the dark. They shifted their focus from dust to light, not the brightness of the star, but the subtle signatures hidden inside its spectrum. Light carries stories that matter cannot speak. Every dip, every peak, every uneven edge in a spectral line is a confession, a trace of heat, a trace of mixing, a trace of something the star may try to hide yet fails. At first glance, the spectral fingerprint looked ordinary, hydrogen dominating, helium layered beneath, and the familiar ladder of metals climbing outward through its surface. But when they stretched the spectrum and separated its components, the pattern changed. The hydrogen lines broadened more than expected. The helium lines, normally modest in older stars, rose slightly, like soft bruises beneath the surface. It was faint, subtle enough to dismiss as an observational quirk, until they compared it with reference stars of the same age and temperature. Only this star showed the elevation. Helium shouldn't be that high up, one of them murmured. In main sequence stars, helium sinks. Gravity pulls it inward. Only violent mixing, intense rotational shear, magnetic disruption, or shock can drag it back up. But this star showed no record of violence, no heat scarring, no rapid rotation, no flare residue. Yet something had lifted helium from the depths and left it near the surface. When they examined the metal abundances, the story deepened. Carbon levels were slightly depressed. Nitrogen was modestly elevated. Oxygen dipped in a way that suggested it had been cycled through higher pressures before returning upward. These were the fingerprints of internal dredge-up material being stirred from deep layers, rising, then settling again. But in a star this stable, that shouldn't happen. Something mixed it, the older scientist said softly. Something reached inside. The team plotted the abundance ratios against stellar models. The mismatches were small, but consistent, exactly the kind expected from an early life disturbance. A temporary inversion of layers, a moment when deeper material rose and outer material sank, then slowly rebalanced over millions of years. A chemical echo, not fresh, not loud, a whisper left behind. The younger researcher enlarged the helium line, smoothing it, isolating its asymmetry. The profile tilted slightly to one side, as if helium had surged upward in a single event, not gradually. A one-time interruption, a moment of internal reversal. That's impossible, someone said. But no one really believed the word. Impossible events had been accumulating since the first night they looked at this star. They computed the mixing timeline. The uplift of helium must have occurred around the same era the core rotation shifted. The star was still young then, barely forming its first stable layers. A disturbance strong enough to tilt the core could also stir the interior. Not strong, the older scientist corrected. Structured, directed. Something had leaned into the cloud, rotated its heart, and stirred its forming layers not with brute force, but with the precision of a hand turning a cup. They turned next to the deeper spectral lines, those that form under the intense pressures inside the star. These lines are tricky. They require careful filtering to separate rotational broadening from thermal noise. But once processed, the lines revealed another strange detail. Elements that normally settle toward the core neon, magnesium, and even traces of silicon were slightly elevated. Not dramatically, just enough to show that the star's interior had once been more mixed than its age suggested. A pattern emerged. The star had felt a stirring from the inside out. They plotted radial abundance gradients. Normally smooth, the gradient in this star contained a faint inflection, a bump, like a ripple frozen in place, a chemical wave. What can freeze a wave inside a star? Someone asked. No answer came, not immediately, but the simulations provided a hint. When the dark binary had drifted through the forming disk, its gravitational contours had twisted the collapsing core. Such a twist might have momentarily inverted thermal gradients, upsetting the normal settling of elements. The deeper layers, heated and compressed, could have surged outward before the collapse stabilized. A gravitational whirlpool, gentle, brief, but enough to stir the star's innermost soup. The chemical scars supported the theory. They turned to nitrogen, the key to detecting old mixing. Nitrogen rises when carbon sinks. The star's nitrogen was just high enough to indicate that carbon had been cycled downward and reprocessed, not by fusion, by mixing. A signature of an internal churn. The team looked again at the core model. The rotational imprint seeded during formation would have created shear layers, thin regions where the old and new rotations fought quietly. Shear can mix material, but slowly and not deeply. Yet the chemical scars were too deep for shear alone. Something else acted with it, the younger researcher said. Something assisted the shear, strengthened it. She highlighted the neon anomaly again. Neon only moves upward if a shock loosens the layering. A shock without heat. A shock without turbulence. A shock that leaves no thermal wound. Gravitational shock, the older man whispered. Not compression, not impact. A tidal moment. A tidal moment occurs when a passing object's gravity stretches a forming region, not ripping it apart, but elongating it enough to destabilize equilibrium for a moment. A faint tidal stretch, like the pull of a moon on an ocean, but acting on plasma instead of water. If the dark binary passed close enough, its combined gravity could create such a stretch. Not enough to shred, enough to stir, and the star's chemistry would remember that stir forever. They re-examined the profiles. Carbon slightly depleted, nitrogen slightly elevated, neon pushed upward, helium higher than expected. A set of fingerprints not matching any known stellar category. A signature. If this pattern appears in another star, the younger scientist said, we'll know it experienced the same thing. Another added, we'd know the travelers passed twice. They looked at each other. The room inhaled. No one exhaled at the same time, because a footprint in rotation was extraordinary, but a footprint in chemistry that was evidence that could propagate across light years. It meant the travelers could be tracked, not by their presence, but by the scars they left in the stars they brushed. A sequence of chemical anomalies printed across the galaxy, like beads on a string. A trail. The team returned to archival data, pulling spectra from stars, showing minor rotational inconsistencies. Most were noise, but a few, just a few, carried similar chemical inflections. Subtle, easy to dismiss, yet unmistakable when placed side by side with the backward star. These stars did not rotate backward, but their chemistry whispered of disturbance. We're seeing the faint ends of the path, someone murmured. The beginning of a map, not of objects, of events. As they studied the chemistry further, something else emerged. The anomalies decayed with depth. The deeper the layer, the fainter the scar, as if the memory were being slowly erased by time. But the surface still carried the imprint, the part of the star that reaches out to space and writes its autobiography into light. A fading wave, a soft echo, a memory dissolving, but not gone. A slow turn in the dark, preserving what physics alone could not explain. The team now saw the star differently. It wasn't simply rotating backward, it was telling a story, written in dust, inscribed in rotation, engraved in chemistry, a story of something unseen, passing silently through its birth. They deepened the spectral resolution again, pushing the instruments to their limits, hoping for one more clue. And it came barely a shadow in the data, a slight skew in the silicon line, a faint asymmetry, a tilt so small it bordered on imagination. It suggested a brief inversion, an instant when silicon, normally buried in the deep, flirted with the higher layers before settling back down. A single moment when everything inside the star shifted upward, downward, sideways, a soft internal earthquake without sound, a tidal whisper. The chemical scars were not random, they were synchronized, aligned with the inferred passing of the dark binary. The star had not simply been nudged, it had been moved slightly, quietly, but deeply, and the chemistry was the last remaining proof of that moment. Outside, the star continued shining, its backward spin steady, the scars beneath its surface softening with age, but never fully erased. Inside the lab, the scientists sat with the knowledge that they were no longer studying a single star's anomaly, they were uncovering the remnants of an encounter older than any record, written not in matter, not in motion, but in the quiet way elements are rearranged when gravity brushes through a forming world, a memory coded in atoms, a whisper sealed into spectra, a slow turn in the dark that began long before the star learned how to shine. They turned next to the magnetic data, the quiet pulse humming beneath the star's surface, a rhythm so faint it nearly drowned in the noise until they knew what to listen for. Magnetic fields in stars behave like breathing creatures. They swell, tighten, relax. Cycles come and go, fields flip, but none of it is perfectly regular. Stars are turbulent by nature. Yet this star, carried a magnetic beat that was too steady, too calm, too measured. A delay repeated over and over, a soft lag in the crest of its magnetic wave. Not random, not chaotic, but timed, like the last heartbeat of something that once moved inside it. They began by isolating the star's magnetic cycle. The overall field strength was normal. The polarity flipped at the expected interval, but hidden deep in the substructure beneath the main magnetic rhythm was a pulse, a faint, delayed echo. It repeated every rotation, always trailing the main signal by the same subtle margin. The offset was tiny, barely a fraction of a percent of the rotation period, but unwavering. A memory so soft it felt like a whisper waiting inside the star. What if this is the core speaking? The younger researcher wondered aloud. The older scientist nodded. Magnetic lags like this come from differential rotations, but not like this. This one doesn't drift, it holds. Differential rotation normally evolves over time. Layers slow or accelerate as stars age. Nothing remains fixed. But this lag was fixed, locked, as if anchored to something that no longer existed. They plotted it across the full observation window. 5 nights, then 10, then data from older archives. The lag was identical, unchanging, steady. Something imprinted this, the older scientist whispered. But nothing inside the star now could be causing it. The team zoomed deeper. They smoothed the magnetic curves, filtered out high-frequency noise, stacked the signals from different angles, letting the star's own rotation reveal its hidden heartbeat. The echo sharpened. It wasn't chaotic. It wasn't decaying the way internal noise should. It was layered, a soft, spiraling pattern that seemed almost too deliberate, a slow turn in the dark, repeating, enduring. They aligned the magnetic echo with the rotational jitter they had mapped earlier. And when they overlaid the two, rotation versus magnetic response, something happened that made the room lean closer. The curves touched, not perfectly, just enough to suggest a connection. The rotational irregularities, tiny, almost imperceptible shifts in the timing of the spin, matched the rhythm of the magnetic echo. It was as if the star were breathing twice, once on the surface, once deep within. "The core is out of phase with the surface," someone whispered. Not unusual. But the phase difference in this star was fixed, precise, and ancient. A fossilized phase shift. In most stars, magnetic echoes drift with evolution. But this one had not drifted at all, implying the difference was established at formation and preserved ever since. Preserved like a scar. They reconstructed the internal rotation profile, a notoriously difficult task. But with enough data pulsation modes, spectral broadening, and the magnetic lag, they built a layered model of the star's interior. And deep beneath the convective exterior, they found the signature of a rotation that felt different, smoother, slower, older, as if the core were still carrying an axis from a time before the outer layers formed. What could freeze a rotation profile like that? Someone asked. The answer came quietly from the corner of the room. A tidal field in motion, a moving gravitational contour, the kind produced by a passing system, the kind produced by the dark binary they suspected. They ran simulations again, this time focusing on core dynamics. If the traveler's tidal field introduced a slow, spiraling distortion during collapse, the core could inherit a faint, secondary rotation, not strong enough to dominate immediately, but stable enough to persist indefinitely. The lag they saw was the echo of that ancient tilt, a whisper left behind by gravity. As they animated the simulated core, the motions resembled a spiral unwinding softly, like ink dispersing in water, and when the outer layers settled, they aligned with the primary rotation. But the core, its seed already altered, continued in its own direction. Two rhythms, two layers, one star. And over millions of years, the core's rhythm exerted influence, pulling the surface into alignment with its reverse direction, until the entire star turned backward. Not suddenly, not violently, but inevitably. A slow turning inward, becoming outward, becoming everything. The magnetic lag was the last remnant of the two-layer past a tiny delay where the outer magnetic field hesitated, waiting for the deeper rhythm to finish its turn. A hesitation born of memory. The younger researcher zoomed even deeper into the magnetic oscillations, filtering them with a method normally used for seismology. A faint subharmonic appeared, a lower tone beneath the primary magnetic cycle. Stars hum, all of them. Their magnetic fields ripple with sound like waves from convection and rotation. But this hum carried two tones, one bright, modern, surface-bound, and one ancient, a lower whisper from the core. The star was singing with two voices. The team isolated the lower tone. It pulsed at the same period, suggested by the gravitational corridor, the same rhythm the dark binary would have carried as it drifted through the forming cloud. A matching frequency, a matching imprint, a gravitational signature frozen into magnetic motion. The older scientist closed his eyes. "The core isn't rotating like a star," he murmured. "It's rotating like something else." The younger researcher frowned. "Like what?" "Like it's echoing the passage of another mass. Stars rarely mimic external objects. They collapse according to their own physics. But this star carried a borrowed rhythm, a slow turn in the dark that wasn't its own. They took the lower tone and stretched it across the timeline. Something strange happened. When extended, the tone wasn't perfectly regular. It had a slight oscillation, a tiny shift, repeating every few cycles, exactly like the orbital wobble of two bodies circling each other. A dark binary signature, encoded in a star's magnetic heartbeat. It was the faintest imprint imaginable, time-worn, diluted, nearly erased, but still present, still breathing beneath the star's surface. "This star is remembering an orbit," the older scientist whispered. "An orbit no longer present, a pair long gone, a passage millions of years old, and yet here it was embedded in magnetism, preserved in rotation, etched into chemistry, a memory surviving across the lifetime of light itself. They merged all data, magnetic lag, rotational split, spectral scars, and let the star tell its story in one full motion. The resulting model rendered slowly, softly, like a dream being assembled. A forming cloud, a passing traveler, a dark companion twisting space-time around it, a tidal brush, a layered core, a seeded rotation, a magnetic echo that outlived the event, a star born of two directions, but loyal to the deeper one. A star that turned backward because something passed once through its cradle and left behind a rhythm of its own. The room fell silent, not because they lacked words, but because every word felt too small. The star rotated once more, on-screen smooth, reversed, unwavering, carrying within it the ghost of an orbit that belonged to something that does not shine. A slow turn in the dark, still echoing. They had mapped the magnetic echo, traced the chemical scars, reconstructed the parting of the disk. All of it pointed toward a single, haunting truth. The star's backward spin began before the star itself fully existed. And yet something still felt incomplete, like the outline of a shape without its interior, a footprint without the weight of the creature that made it. What exactly passed through the cloud? The question resurfaced, softer now, not as speculation, but as necessity. They had assumed mass, a compact remnant, a dark companion, a binary drifting through space. But when they modeled the traveler's influence using mass alone, the results strained. Mass could twist, nudge, bend. Mass could seed a rotation, but it couldn't explain the magnetic signature. It couldn't explain the chemical uplift. It couldn't explain the distortion curves that suggested not just gravity, but flow. Something more than mass had passed through the cloud. They returned to the dust asymmetry, studying its shape deeper, almost obsessively. Dust bends around gravity. Yes, but dust also bends around wind, if the wind is gentle, structured, and cold. Stellar winds are hot and turbulent, but there exist other winds in the universe. Winds that do not glow, winds that come from dying stars, or from objects shedding charged particles in the deep, quiet dark. Plasma streams. But not the kind released by ordinary stars' plasma that is cold, faint, and barely ionized. The final breath of a remnant cooling into silence. A wind that would be invisible in light, but unmistakable in its effect on charged particles. What if the traveler wasn't just massive, the younger researcher said, but active? Active in a dying way. Active the way an ember still releases heat even after the flame has gone. Active the way ancient remnants exhale the last traces of their existence. A cold plasma stream could slip through a forming cloud like a ghost, not burning it, not pushing it, but threading through it, decoupling the inner rotation from the outer flow. Gravity alone might tilt the core, but a plasma stream that could stir it. They examined the curvature of the trough again. It had always seemed strange that the dust parted in two asymmetric channels. Gravity alone pulls symmetrically, but plasma winds, charged flows, shaped by magnetic fields, are never symmetrical. They arc, they drift, they ripple with the dying heartbeat of whatever object emits them. One of the simulations added a weak plasma stream to the traveler. The cloud behaved differently. The core tilted, yes, but the outer layers, they rippled just slightly, creating patterns in density that matched the faint spiral they found in the dust. A slow, spiraling tread not carved by mass, but brushed by a current. The older scientist leaned toward the screen, his eyes narrowing. "We've been assuming the binary was quiet," he murmured. "What if it wasn't?" Dying stars whisper too. Not in light, in plasma. A white dwarf shedding its final ribbons of charged particles. A neutron star hissing with residual magnetism. A brown dwarf exhaling ions in the cold. Any of these could create a structured flow, a ghost wind weaving through the cloud. Plasma would interact with the protostar differently, the younger researcher added. It would twist the magnetic fields first. The core would follow the fields. The outer layers would follow gravity. A double influence. Two forces at once. A perfect recipe for a layered memory. They turned next to the magnetic echo again. The lower tone, the ancient hum, had a substructure they hadn't noticed before. A tiny tremor, repeating at intervals too small to matter, until they matched those intervals with typical frequencies of plasma stream instabilities. The match was subtle, but real. The star's magnetic echo carried not only the rhythm of the object's gravity, but the dying tremor of its plasma, a relic of a relic. The realization grew slowly, like dawn creeping across a quiet horizon. What if the star didn't just inherit a rotation, the older scientists said, but a pulse from something that drifted through the cloud, shedding its final breath, a pulse carried into the star's core, a pulse still humming there, buried under layers of fusion and time. A slow turn in the dark, accompanied by a second, fainter heartbeat. The younger scientist isolated the tremor, amplifying it until the pattern became visible. It wasn't smooth. It had patches, oscillations, tiny knots, exactly the kind produced by turbulent plasma flows constrained by a magnetic field. This was not an object merely passing. This was an object exhaling, a dying remnant shedding its last structured wind. The chemical scars made more sense now. Helium uplift, neon disturb, silicon shift. These were signatures of a plasma sweep, ions carrying momentum inward, stirring deeper layers before they had fully settled. The disk split also came into focus. Gravity parted it. Plasma curled the edges. Two forces, two paths, two trails. A binary, yes, but one partner, alive enough to breathe, and the other so dark it may never have shone at all. They built a comprehensive model, mass plus plasma plus rotation. The moment the simulation ran, the star's past unfolded like a slow-motion memory, a cloud collapsing, a dark binary wandering through, a cold plasma stream brushing the inner disk, twisting the magnetized heart of the forming star with delicate precision, gravity shifting the seed, plasma stirring the soup, a pair of trails parting the disk, a magnetic echo etched deep inside, a layered rotation forming, a slow, inevitable reversal. The simulation ended with the star spinning backward, its magnetic lag repeating in the same haunted rhythm they observed, its chemical scars aligned, its dust parted in twin arcs. Everything matched, not perfectly, never perfectly, but clearly enough that the truth became unavoidable. The event that shaped the star was not a collision, not an impact, not a strike. It was a brush, a passing, a touch so soft the universe itself needed millions of years to confess it. The forgotten impact was not an impact at all. It was a tidal whisper carried by plasma, left behind by a binary, half alive, half dark, wandering through the cloud like a ghost drifting across sleep. And the star, still turning backward tonight, was its only surviving witness. A slow turn in the dark, carrying a memory that never belonged to it. A memory left behind by something that should not have been able to leave anything at all. They began to treat the star's rotation differently, not as a measurement, not as a number, but as a sentence. A long, unbroken sentence written by forces no longer present, repeating itself with every turn. The deeper they looked, the more the star resembled not an object, but a chronicle, a record kept not in matter, but in motion. Most stars tell their stories through their light. This one told its story through its turning. Rotation is a form of memory, whether stars intend it or not. Every force that touches a forming core leaves something behind, an imprint, a tilt, a rhythm embedded in the very way the star decides to move through time. Even after its surface burns and its light evolves, rotation carries traces from its first breath. And this star's rotation carried too many traces, too layered, too contradictory, too calm. It spun like something that had resolved a conflict long ago, a conflict we were only now beginning to hear. The younger researcher lined up models of the star's rotation, across different ages. The earlier stages, the phase when it was still forming, showed the expected chaotic turbulence, the usual uneven motions. But as the simulation advanced toward its current age, the rotation smoothed itself. It wasn't natural smoothing, it was settling, the way a pendulum finds equilibrium after being nudged. "What are we looking at?" someone asked. "Time," she replied. "We're watching the star negotiate with its past." In the curves, those soft, unhurried arcs, they saw the history of that negotiation. The core, carrying a borrowed direction. The outer layers, reluctant to yield. The magnetic fields, lagging, adjusting. The chemical signatures, fading like old ink. It was as if the star had spent millions of years trying to reconcile two beginnings, one given by its birth cloud and one given by the passing travelers. "What happens," the older scientist whispered, "when a star is born twice?" The question lingered. Most stars have a single origin story. This one had two, one visible in its light, the other hidden in its spin. The team animated the layered rotation again. They watched the deeper rotation slow, reversed, unwavering move, like a second heartbeat beneath the surface. The outer rotation followed, reluctantly at first, then increasingly aligned, until the entire star adopted the core's rhythm. It was a history written not in chapters, but in turning, a biography carried through motion. The younger researcher turned down the simulation speed, slowing the nested rotations until they resembled two translucent shapes shifting through each other, one bright, one dim. The dim rotation, the core's ancient memory, was so slow that it looked almost still, a slow turn in the dark, the beginning of everything. "That's the original imprint," she said softly. The moment the cloud was touched, the outer rotation, bright and swift, orbited the slower one, like a second narrative, drawn into alignment over time, not forced, not snapped, but persuaded. The star hadn't been made to comply. It had simply learned, layer by layer, to follow the deeper beat. "Stars evolve," the older scientist said, "but this looks more like surrender, not defeat, acceptance. The way a river adjusts its flow around a stone, the way a tree grows toward a slant of light, the way a memory outweighs every new story that tries to cover it." The researchers then traced the time it would take for the surface to fully match the core's reversed direction. The math showed something poetic. The shift wasn't abrupt. It happened over an interval that matched, almost perfectly, the decay rate of the magnetic echo. The star adopted its backward spin at the same pace its memory of the passing traveler faded. "History shaped it," someone whispered, and then history sank into the core. The group sat quietly, letting that truth settle. The backward rotation was a message, yes, but it was also a memorial. The star wasn't simply reacting to something long gone. It was preserving the ghost of it, keeping it alive through motion alone. A history written not in words, not in light, but in turning. The more they studied the star, the more they realized, stars do not forget. Not entirely. Rotation is one of the few cosmic traits resistant to time. Light changes, temperature changes, chemistry shifts. But rotation, unless disrupted, persists. It is the one thing stars carry from their earliest moments to their last. And this star carried a rotation that never belonged to it. A rotation it accepted, adopted, and now performed with quiet fidelity. The older scientist, who had spent decades listening to stellar oscillations, leaned back and said, "Maybe the universe has its own form of storytelling. Not through sound, not through images, through motion." They began to wonder, how many stars carry histories we cannot hear? How many spins hide ancient encounters? How many memories turn silently in the dark? Rotation as narrative. Rotation as witness. Rotation as the one language gravity never mistranslates. They reconstructed the star's entire life, a timeline not of light curves, but of spin curves. Each point on the graph represented not brightness, but orientation. They watched the angles move, twist, align, drift, settle. It was like watching a person's life represented by the tilt of their head, the posture of their body over years, the subtle changes that betray the moments that shape them. What if every star is full of events we can only read this way? The younger researcher asked. Then we've been deaf, the older scientist replied, to the universe's quietest language. They sat with that thought, and the star kept turning. In that steady backward revolution, they felt the presence of time, not the linear time humans learn to measure, but cosmic time, the time that stretches and folds and carries histories in rotations rather than in eras. They imagined the moment the cloud was touched, a dark traveler drifting through, a faint plasma tide brushing against forming matter, a core tilting softly, a memory seated deep. And millions of years later, after dust settled, after light ignited, after nuclear fusion stabilized, that memory still turning, a slow turn in the dark. The star did not remember the object consciously, of course, but stars remember the way trees remember wind by the angle of their growth. They remember the way oceans remember tides by the patterns carved into their shores. They remember in the language of motion, and this star's motion was a testimony to an encounter that would otherwise have been erased, a soft collision between existence and non-existence, between visible matter and something that passed silently through. The more they listened, the more they understood. The star wasn't telling them what it was. It was telling them what had happened to it. Its backward spin was not rebellion, it was inheritance. A history written slowly, faithfully, quietly, into the only part of itself that time could not unmake. The researchers looked again at the model, the double rotation, the magnetic echo, the fading chemical scars. It was all there, waiting to be read. And as they prepared to study the next layer of data, the star completed another gentle revolution, backward, serene, unhurried, carrying its memory through the dark as if turning the page of a book no one else could hold. They searched outward, now away from the star, away from the chemical scars and the magnetic whisper, and into the broader fabric of the surrounding sky, looking for whatever had once passed through and left such a quiet wound. The idea was simple, almost impossibly so. If something moved through the star's birthplace, it would have moved on. And if it moved on, it might have left other traces in its wake, in the motions of neighboring stars, in the drift of dust clouds, in the microscopic tugs recorded by the gravity of the region. Nothing in the universe moves without consequence, not even something that leaves no light behind. So they widened their scope 12 light years, then 20, then 50, searching for subtle perturbations. The corridor they had already mapped curved gently across that space like a line drawn by a gravity they could not see. But the farther they extended it, the more the line frayed, splitting into 3 possible trajectories. The traveler had not been moving in a straight path. It had been wandering. Wandering objects leave signatures differently than objects on stable orbits. Their trails do not remain crisp. Their influence fades unevenly, spreading like ripples across a slow-moving tide. But even a wanderer cannot hide entirely. As they examined proper motion data, tiny shifts in the positions of stars across centuries of observations, they found something unexpected. A handful of stars along the projected path showed minute, synchronized deviations in their velocity vectors. Not enough to call anomalous, just enough to say something nudged them. A gentleness repeated across space. They drew a vector field of these deviations, tiny arrows pointing in directions that barely differed from each star's expected path. When the field was complete, the arrows formed a faint bow shape like the wake of an unseen ship. "What caused that bow?" someone asked. The room grew still. Wakes are made by travelers, but only those massive enough, concentrated enough, or slow enough to pull matter with them. Whatever moved through this region did not merely pass, it shaped motion behind it. A vanished neighbor. The younger researcher overlaid archival infrared data, searching for remnants, glowing embers of dead stars, lingering heat, stray radiation. But the region was dark. too dark. It was a quiet so profound that it felt intentional, as if something had taken its heat with it, leaving nothing but shadowed gravity behind. Yet one star, just one, caught their attention. A faint red dwarf, ordinary in every way except for one. Its trajectory was wrong. Not catastrophically wrong, just slightly skewed, drifting off its predicted path in a direction consistent with the corridor they traced. The deviation had begun about 30 million years ago. The same time the star with the backward spin was forming, the dwarf had been nudged subtly, but unmistakably, by the same traveler. They pulled data from Gaia, from Hipparcos, from older catalogs digitized from photographic plates decades ago. The red dwarf's deviation persisted through every dataset, always pointing along that same silent arc. That dwarf felt something, the older scientist whispered. Something that changed its motion just enough for us to see. When they rewound its path using stellar kinematics, they discovered something startling. The dwarf had not originally been part of this region. It had drifted into the neighborhood after being gently pulled, redirected, set upon a slightly altered course. Not violently, not abruptly, just rethreaded. As if it was caught in the edge of a gravitational wake, the younger scientist murmured. But wakes fade quickly, another argued. Unless, the older one added, the wake belonged to something massive enough or dense enough to carry its influence farther than normal. Something massive, something dense, something dark. The trail grew clearer. The red dwarf became a marker, a breadcrumb in a cosmic forest. Using its deviation, they triangulated the traveler's likely path. The corridor sharpened. The frayed projections narrowed, and slowly, three paths became one, a single trajectory, long, graceful, turning ever so slightly toward emptiness. The traveler was moving toward a sparsely populated region of the galaxy, a place where few stars exist to betray its presence, a place where it could disappear into darkness and remain hidden indefinitely. They extended the projection forward, 50,000 years, 100,000, a million, and then they saw it. A cluster of stars ahead, small, dim, old, showing tiny but correlated anomalies in their velocity. Dispersions, not strong enough to be caused by each other, not synchronized by any known gravitational resonance, a soft, collective tug. If the traveler had moved through them, their motions would drift ever so slightly in its direction. And they did, forming a faint fan shape, opening toward the side the corridor predicted. It was like watching dust drift in the wake of a hand that passed through the air long ago. The scientists superimposed the fan-shaped drift with the remnants of the corridor. A perfect alignment, too subtle for nature to fake, too gentle for coincidence, too coherent for chance. Something went through there, the younger scientist whispered. Something with mass, but no light. A neighbor that had once been close enough to leave fingerprints in motion, and then slipped away into the quiet. Not a star, not entirely, not anymore. They checked one more thing, the density field. If a compact object had drifted through this region, it might have left gravitational focusing behind a faint enhancement in the density of interstellar dust along its path. The field confirmed it. A thin streak of increased density, barely measurable, stretching like a soft scar across dozens of light years. Not sharp, not dissipating, just present, like the shadow of a shadow, a streak that matched the corridor perfectly. The vanished neighbor had weight. It had path. It had history. It just didn't have light. The scientists fell silent again, letting the implications settle. For the first time, they weren't dealing with a hypothetical object. They were staring at the ghost trail of a real one. Something that once drifted close enough to touch a forming star, to brush its core, to stir its chemistry, to write a memory into its spin. Something that moved on, quietly, slowly, toward the empty spaces of the galaxy. A slow turn in the dark, leaving behind nothing but altered motions and a star that could not forget. The older scientist finally spoke, his voice barely audible. "If we follow this path far enough, we might find it," the younger one answered with equal quiet. "Or we might find nothing, which would be even more terrifying. Because sometimes nothing is not absence. Sometimes nothing is simply something that does not wish to be seen." They saved the updated corridor map, a map of motion, of echoes, of scars, and looked again at the backward spinning star, shining with a rotation borrowed from a traveler now lost in the dark. Somewhere out there, beyond the reach of their telescopes, beyond the warmth of visible stars, the neighbor moved on, unseen, unlit, unhindered. And the star remained behind, still turning its strange, inherited rhythm, the only witness to a passage that left no light but changed everything it touched. They began to realize the corridor wasn't just a trail, it was a kind of imprint, a shaping, a faint, lingering architecture left behind by something massive enough, subtle enough, and strange enough to sculpt the motions of the region without leaving a single photon behind. Gravity doesn't fade. It stretches, it bends, it lingers. It is the only storyteller the universe never silences. And the more they studied the corridor, the more it felt like gravity itself had remembered the traveler. Not clearly, not sharply, but the way a river remembers a stone long after the current has carried it away in the slight curve of its motion, in the way water swirls where nothing now exists. They modeled the region as it would have been millions of years ago, before the corridor was carved. The simulation, a delicate lattice of dust, gas, and drifting stars, looked unremarkable at first. But when they overlaid the gravitational influence of the dark binary, the picture changed. Space bent, not in the dramatic way of black holes or collapsed giants, but subtly, elegantly, like fabric pressed by a soft hand. That's gravitational memory, the older scientist said. Not a fossil, an imprint. Not the event itself, but the shape the event left behind. The more they pushed the simulation, the clearer the imprint became. The traveler had created a curvature not strong enough to tear space, but strong enough to mold it just slightly. Just enough that matter flowed differently for millions of years after. Even after the traveler vanished, space kept the memory. They zoomed in closer. The very coordinates surrounding the backward spinning star were tilted in a way that defied randomness. Space had not fully relaxed after the disturbance. It held tension the researchers could measure in the epicyclic motions of nearby stars, minute oscillations repeating slowly, whispering the shape of a gravity long gone. What if space itself remembers? The younger researcher whispered. The idea was not new in theoretical physics. Space-time can store curvature, can keep the echoes of passing objects, but this felt different. This was not a ripple, not a wave, not a transient distortion. This was a shape, left behind like a footprint hardened in ancient mud, a shape that had written itself into the star. They studied the region's density map again, an ultrafine grid where pockets of dust and gas had subtly aligned along arcs and soft crescents. Each crescent pointed along the corridor. Each density fluctuation carried the faintest tilt in phase space. A whole region of space had been combed in a single direction. Combings like that do not occur on their own. They require something with a consistent, directional pull. The dark binary, a slow-moving sculptor that shifted the geometry of the space it traveled through. A vanished neighbor that left its signature in the orientation of matter, not a scar, but a memory. They overlaid the star's internal rotation model with the curvature map of the region. What they saw drew a breath from everyone in the room. The angles matched, the core's ancient tilt, the corridor's gentle bend, the magnetic echo's timing, the dust rings thinning, the dwarf's deviations, the density streak, and the region's gravitational curvature all pointed in the same direction. The star had inherited its rotation from the shape of space around it, space that had been shaped by something passing through as softly as breath. It didn't just inherit a motion, the younger scientist said quietly. It inherited a geometry, not a force, a shape, not a push, a guiding contour. The star was turning backward because space itself had once been twisted around it, not violently, not chaotically, but gently, persistently, the way a potter's hand guides clay. A slow turn in the dark, captured by the star the way a seed captures the wind that carried it. One of the researchers pulled up archival data of planets forming in asymmetric disks, how slight distortions in disk geometry change orbital directions. The backward spinning star was a stellar scale version of that phenomenon, but born from something far larger and stranger than a misaligned disk. It's like the star was born in a tide, the older scientists said, and never forgot the direction of the water. They examined the region's gravitational multipoles, an analysis of how mass distributes its influence. The multipoles showed a faint, lingering asymmetry, a directional preference that should not exist in an empty region. Space had a lean to it, as though it still tilted toward the path the traveler took, a tilt that guided matter, a tilt that softened the collapse of the cloud, a tilt that shaped the star. A gravitational memory, the older scientist said again, firmer this time. Space is still, remembering the object. What about the traveler? Someone asked. The room fell quiet. If space still remembered it, then its influence must have been immense, yet so perfectly quiet that no known telescope had ever seen it. Something that could sculpt space-time at macro scales, but leave no light behind. A traveler not only dark, but deliberate. They turned to the star again, and suddenly its backward rotation felt less like an anomaly and more like testimony. The star wasn't contradicting physics. It was obeying the geometry of the moment it was born. Everything that grows inside a curved space inherits that curve. Trees grow warped by leaning winds. Rivers bend around invisible stone. Galaxies twist from the slightest asymmetry in mass. And stars, in their earliest moments, are more fragile than any of them. The forming star had simply followed the easiest path toward the shape space offered it, a shape carved by a passing binary whose gravity was uneven, whose structure was lopsided, whose motion carried with it a turning field that folded space the way fingers fold fabric, a field that curved the cloud's collapse, tilted the core, stirred its chemistry, echoed in its magnetism, and wrote a backward direction into its destiny, a direction that would outlive the cause. Millions of years later, the star turned calmly, faithfully, like a monk reciting a chant handed down through generations. A slow turn in the dark, preserving the shape of an absence that once brushed the world into being. The researchers looked again at the curvature maps, the star's motion, the region's distortions, and they realized something none of them said aloud. They weren't just chasing a vanished object. They were chasing the memory of it, written in space and carried inside a star that had never stopped whispering the story. And space, in its quiet way, was whispering it back. They tried, at last, to follow the traveler itself, not its memory, not the distortion it left behind, but its imagined path through the galaxy. A vanished object can hide from telescopes, but it cannot hide from mathematics. Gravity is an archivist. It saves everything. So they fed the newly refined corridor into a galactic dynamic model accounting for stellar drift, spiral arm rotation, tidal forces from the Milky Way's bar, and historical interactions that shape the surrounding region. The model rendered slowly, lines forming, curves tightening. The faint corridor extended into a long, pale trajectory across the grid, like a string pulled through water. The traveler had drifted at a strange pace, neither fast enough to be a runaway star, nor slow enough to be bound to a cluster. It moved like something half detached from the galaxy's motion, carrying its own internal inertia, dragging a small pocket of curved space behind it. The team followed the path across thousands of light years of simulated time. At first, everything behaved predictably. slight tugs from nearby stars, gentle influence from galactic tides, swells in density where the spiral arms thickened. Then the path bent abruptly, cleanly, unnaturally. What caused that? The younger researcher murmured. No nearby star was dense enough to bend the path so sharply. No cluster close enough. No known object powerful enough. The simulation showed the traveler drifting peacefully, then shifting course by a measurable angle, as though something invisible had reached out and pulled it sideways. The older scientist zoomed into the region of the anomaly. The curvature changed in a way that gravity alone could not produce. It was not a deflection. It was a pivot. Objects pivot only when they encounter forces on both sides, a binary interaction, tidal tension, or a field too complex to describe with mass alone. They examined every catalog from the region. No massive object had ever been recorded there. No remnants, no dark clusters, nothing. Unless the thing pulling it, someone whispered, was just as invisible as the traveler itself. The room sank deeper into silence. Two dark objects, two unseen masses, two wandering shadows in the galaxy. If they met briefly, softly, the gravitational consequences could be immense, yet invisible to all instruments but motion itself. A brief interaction could change direction without leaving light, heat, or remnants. A dark encounter between dark travelers. The simulation continued. After the pivot, the traveler's path elongated, its arc stretching into a long, graceful sweep through an emptier region of the galaxy, where stars grew sparse and the density of matter fell near zero. There, the trajectory began to blur, not because the simulation lacked data, but because the real sky did. The path extended into a region where observations thinned, where Gaia's precision lost its edge, where older catalogs had gaps, a place where the galaxy grew dim, a place where something could hide forever. The younger researcher rewound the simulation, freezing the pivot point. "There must be something here," she whispered. "We just can't see it." The older scientist nodded slowly. Gravity doesn't change direction on its own. So they searched for evidence of a second traveler, another invisible mass moving through the galaxy without announcing itself. They looked for perturbations, for anomalies in proper motion, for density distortions, for anything out of place. At first, nothing, just smooth sky. Then someone noticed a peculiar pattern, a cluster of stars showing slight but consistent radial accelerations, not pointing toward any known mass, not a large acceleration, just a whisper like the touch of something passing by. The pattern formed, a crescent, mirroring the shape found earlier, but located far along the traveler's projected trajectory. A second wake, fainter, older, more eroded by time but real. A wake that did not belong to the original traveler. Two wakes, separated by millions of years, but lying along the same broad path. Two dark travelers crossing the same region of space, like shadows meeting briefly in a quiet corridor. Could they have interacted? The younger scientist asked. In that pivot, the older one replied. They might have. In the curve of the pivot, in the sharpness of the bend, in the absence of light, they saw the signature of a gravitational meeting between two unlit bodies. Not a collision, not a merger, a passing, a mutual tug, a dance too quiet for light to notice. A slow turn in the dark, binding two unseen wanderers for a moment before they drifted apart again into separate nights. They followed the weaker wake, mapping its direction, its curvature, its destiny. It vanished into an even emptier region than the first wake, a place with almost no stars, a patch of sky that astronomers had long ignored because nothing happened there, nothing glowed, nothing moved fast, nothing interesting. But now, silence itself felt suspicious. Is it possible, someone whispered, that there are entire populations of objects like this moving through the galaxy unseen? The older scientist answered without hesitation. Yes, but until now, none left a memory strong enough for us to notice. The room exhaled together. The backward spinning star, with its tilted core, its layered echoes, its chemical scars, its parting dust, its inherited geometry, was not just an anomaly, it was evidence, a rare, precious evidence of what happens when dark wanderers pass through the living fabric of a galaxy, a testimony from matter touched by something it could not see. The researchers returned to the traveler's last trace, a bending path fading into emptiness. They zoomed into the region where the data abruptly disappeared. There was no failure in the simulation, no glitch, no miscalculation, just absence. A void so complete it felt unnatural, as if something had erased the possibility of knowing. The younger researcher stared at the hollow patch. "Why does the data stop here?" she whispered. And the older scientist, with a voice that felt like it belonged in the dark between stars, said, "Because whatever touched the star did not want to be found." They stared at the emptiness, a silence that did not feel empty at all. The star far behind them kept turning, faithfully echoing the memory of the traveler that space could no longer show. A slow turn in the dark, preserving the last trace of something that slipped away more quietly than gravity should allow. They began the reconstruction the way an archaeologist rebuilds a vanished city, piece by fragile piece, letting the smallest clues shape the architecture of an event no one witnessed, but whose aftermath lingered everywhere. To understand the star, they needed to understand the night it was born, wrong, the moment the forming cloud felt a presence that would become its permanent shadow. They gathered every shred of data, the dust geometry, the chemical uplift, the magnetic lag, the curvature of space, the corridor of disturbed stars, the pivot where the traveler changed course. Each fragment was incomplete alone. Together, they formed something like a memory. "Let's run it backwards," the younger researcher said. So they rewound the star's life, not in light, but in motion. The simulation reversed the star's rotation, its layers unfolding, its magnetic fields undoing their cycles, its chemistry sinking slowly back into equilibrium. The dust ring departed, closing its thin wound. The region's gravity relaxed, straightening its soft lean. Stellar motions unwound their subtle deviations. And then the star itself vanished, reverting to the cloud it had once been, a cold mist, a drifting, collapsing shadow, a cradle waiting for a touch. They let the cloud stabilize for a moment, its particles suspended in the vast, quiet darkness, nothing to distinguish it from millions of other silent nurseries. Then they introduced the traveler, not with light, it had none, not with heat, it carried none. They introduced it as curvature, a moving distortion, a pocket of reshaped space drifting toward the cloud. The first thing the cloud felt was pressure change, a soft tidal elongation, stretching it along one axis, compressing it along another. The model responded instantly. The densest part of the cloud, the future core, tilted by a fraction of a degree, barely anything. A single silent suggestion, a gentle hand placed on a turning wheel. As the binary drifted closer, the simulation shifted tone. The remnant's gravity pulled a little more strongly. The dark companion tugged more faintly, its influence washing through the cloud like a shadow passing beneath water. The cloud bent, not enough to rip, just enough to bow. A few thousand kilometers from the protostar's center, the tidal tension reached its soft peak. "What happens now?" someone asked. They advanced the simulation frame by frame. At first, nothing, and then everything at once. A tiny swirl of plasma, still forming, hesitated and rotated a fraction backward. Just a fraction, but that fraction was the seed. A seed of reversed rotation. The protostar did not understand what had happened. Stars do not think, but matter does respond. And so the cloud, following its own physics, continued to collapse, except now its densest heart was turning differently from its shell. Layer by layer, the star's future was being written. The binary passed through the disk next. Gravity parted it softly, gently, cleanly. The simulation showed dust flowing aside like silk being brushed by fingertips. Then came the moment that stopped the room. A faint current, barely visible, unless the filters were tuned perfectly, drifted from the remnant. A cold plasma exhalation. Weak, old, but still structured. It swept through the cloud, curling around the inner regions, like smoke winding through tall grass. The charged particles of the cloud responded instantly, twisting into tiny vortices. The magnetic field, still embryonic at that stage, caught the shape of the plasma stream and folded inward. The forming core bent with it, aligning itself to the foreign field for a heartbeat just long enough to alter the future forever. The older scientist whispered, "There. That's the night. That's when it happened." The plasma stream barely lingered. The remnant drifted onward, trailing its dark companion. The trough closed behind them. The cloud swelled back into place. Within moments, it looked unchanged. But the star-to-be was no longer the same. The core carried a borrowed axis. The magnetic seed carried a foreign rhythm. The chemistry carried a tiny ripple. The dust carried twin channels. The region carried a faint curvature. A memory had been planted, not in words, not in images, but in direction. The simulation continued. The cloud thickened. Temperature rose. Pressure built. Nuclear ignition loomed. The outer layers spun in the original direction. The inner core spun in the new one. The mismatch created a gentle shear, mixing material upward. Helium rose. Neon shifted. Carbon descended. The chemical scars began forming even before the star's first light. And when the star finally ignited, its birth was quiet. Its light rose as any star's light would. Nothing in its glow betrayed the night a shadow had passed through its cradle. Nothing in its brightness revealed it had been born at an angle. Stars do not scream, they simply turn. And this one turned wrong from its very first moment, slowly at first, then steadily, then faithfully. A slow turn in the dark. The simulation faded, leaving only the star on the screen, fully formed again, rotating backward with the softness of a memory repeating itself. The younger researcher whispered, "It wasn't a catastrophic event. It was barely an event at all." The older scientist nodded. "And that's why the star remembers. Because the touch was gentle enough to leave no wound, except the one in its direction." They replayed the reconstruction again, slower, this time watching the traveler slip through the cloud, carrying the quiet machinery of its own gravity and its dying breath. A single brushstroke across a forming star. A single tilt in a newborn axis. A single whisper inside the magnetic seed. A single moment that space chose to keep the night the star was written. Not in fire, not in fusion, not in brilliance, but in motion. And millions of years later, across the emptiness of space, the star was still turning that moment forward, as if the memory had never ended. They had replayed the night of the star's shaping enough times to know it intimately. The tidal elongation, the slight lift in the core, the whisper of plasma threading through the cloud, the moment when direction was rewritten. But there was a question that none of them had yet dared to confront. If the star's rotation had been altered so deeply, so fundamentally, where was the energy that should have been released? Rotation is not free. Changing it requires work, violent, loud, destructive work. A torque applied at the wrong time can rip a forming star apart, can heat it, can scatter its progress. Matter can leave scars so obvious they glow across millions of years. But this star showed none of that. The reversal was smooth, soft, low cost, as if the universe had found a shortcut around its own rules. How much energy should have been lost in the reversal? Someone asked. The older scientist typed quickly, modeling the angular momentum shift the star should have undergone. The numbers rose, grew heavy, then heavy again, a mass of energy large enough to vaporize moons. Then he compared the expected loss with the actual one inferred from the star's brightness history. The room fell still. The real energy loss was a fraction, a sliver, barely a whisper compared to what physics predicted. "It's too low," the younger researcher murmured. "Much too low." "Where did the rest of it go?" another asked. Silence again, the kind that feels like space listening. They recalculated, adjusted variables, added turbulence, subtracted magnetic drag, modeled pressure waves. Nothing filled the gap. The star should have shouted its reversal. It should have broadcast the event across the spectrum: thermal spikes, shock ripples, convection bursts. Instead, it barely sighed, a slow turn in the dark. It behaved as if the reversal cost almost nothing, someone said. "But that violates every conservation law we know." The older scientist leaned forward. "Unless," he said, "the energy didn't vanish, unless it was distributed, diffused, smoothed out, not destroyed, not radiated, but carried away by something else." "What could carry it?" the younger one asked. He pulled up a visualization, the traveler's plasma stream passing through the cloud, charged particles weaving around magnetic seeds, a field shaping another field. A thought grew in the room, as quietly as dust collecting on glass. What if the traveler absorbed the excess momentum? It was absurd. It was impossible. It was elegant. Angular momentum transfer is common between colliding bodies, but between a forming star and a passing remnant, with nothing but a whisper of plasma between them? Unthinkable, but not impossible. The simulation gave it weight. As the traveler passed, the cloud's rotation shifted. A small portion of its angular momentum transferred into the plasma stream, which then dissipated into the traveler's own magnetic shell. The older scientist sat back. "It's a coupling," he whispered. "A gravitational magnetic coupling. Not collision, not torque. A sharing, a handing off." The forming star did not reverse itself by spending its own energy. It reversed itself because something passing through took part of the rotational burden away. The traveler had not simply nudged the star, it had participated. It had acted like a sink, absorbing momentum, light as breath, soft as shadow, leaving the star calm and whole. A reversal not imposed, but negotiated. The star gave up part of its inherited spin, and the traveler carried that rotation forward, adding it to its own silent drift. "Can we model how much momentum the traveler would have absorbed?" someone asked. They did. The numbers matched almost perfectly the missing energy from the star. Not all of it, just enough. Enough to explain the star's serenity. Enough to explain the lack of scars. Enough to explain the absence of heating events. The traveler had acted like a sponge, a dark sponge moving through gravity. A structure capable of coupling rotational energy through its magnetic and tidal fields without interaction with light at all. When they ran the model forward, the traveler sped up just slightly after the encounter. A faint acceleration, a quiet inheritance. A trace so small that only a gravitational wake tens of millions of years old could have betrayed its passing. The younger researcher whispered, "So the star didn't lose the energy, it gave it away. And the traveler kept it," the older scientist added, "carrying a piece of the star's former rotation with it across the galaxy. A gift, a theft, a memory, a redistribution. It's like the momentum didn't vanish," she said. It moved. The room sank deeper into thought. Momentum moving from one body to another through plasma, through dark mass, through curved space, a mechanism that had no name, but the star had remembered it. In its tilt, in its chemistry, in its magnetic heartbeat, in its backward turn. They studied the star again, its serene revolution, its perfect calm. Not a star wounded, a star balanced, perfectly balanced, because something had carried away the imbalance without leaving a scar. A slow turn in the dark, paid for not by the star, but by the traveler. The older scientist finally said what everyone was thinking. This wasn't a random encounter. It behaved like an exchange. Not intentional, nothing conscious, but physical. Elegant, precise, an exchange of direction, an exchange of momentum, an exchange of memory. The star traded part of its original motion for part of the traveler's passing field. And that's why it's calm now, the younger researcher said. It isn't fighting itself anymore. It settled long ago. The star had found equilibrium because the event that could have torn it apart had instead been softened by a traveler built to absorb what stars could not. A dark companion drifting through the galaxy, quietly collecting the rotational signatures of the worlds it brushes. A wanderer whose gravity is a library, whose plasma is a pen, whose motion is a record keeper of everything it touches. The star was simply one page in the traveler's long, silent archive. And millions of years later, the page still turned backward, slowly, calmly, faithfully. A slow turn in the dark, carrying the memory of the moment when its burden was lifted and taken away by something the universe never meant for eyes to see. They started to look at the star differently, not as an anomaly that needed explanation, but as a creature shaped by circumstances no textbook had ever allowed. A normal star follows rules. This one followed history. And that distinction opened something vast. They gathered the data again: rotation, chemistry, magnetic signature, dust geometry, regional curvature, laid it out in silence, and saw a pattern that no one wanted to say aloud at first. The star didn't fit into any established category, not type A, F, G, K, not peculiar, not chemically peculiar, not magnetically bizarre, not rotationally abnormal in the way known stars are. This was something else. A quiet violation of classification. What are we even looking at? The younger researcher whispered. The older scientist didn't answer immediately. He stared at the rotation profile, its two layers moving like overlapping memories, and traced the line where the transition between them had once lived. A boundary that no longer existed. A boundary the star had smoothed away over millions of years. Finally, he spoke. Maybe this is a different kind of star. One defined not by mass or heat or spectrum, but by the story of how it was born. A star of memory. The phrase settled into the room like dust settling onto an untouched table. They ran comparisons against the entire Gaia dataset, filtering for rotational inversions, looking for faint chemical uplifts, searching for magnetic lags, dust asymmetries, microcurvatures in local gravity fields. Most stars followed the expected patterns, but a few, not many, but a few held hints of something familiar. A slight rotational flattening inconsistent with their age. A nitrogen elevation not explained by fusion cycles. A magnetic lag too steady for internal turbulence alone. A dust scar half erased by time. Subtle signals, scattered like faint echoes across the galaxy. What if, the younger researcher began slowly, there are others like this? What if this isn't a single event, but a type of stellar formation no one's recognized because the signs are too quiet? The room grew still in a new way, not fear, not awe, but the heavy feeling that a curtain was lifting on a stage they'd never known existed. Stars with inherited motion, stars shaped by passing travelers, stars whose cores carried borrowed directions, stars whose histories were written by encounters, not alone by collapse. Are we talking about a new classification? Someone asked. A new subclass, another whispered. A new process, the older scientist corrected. A way the galaxy makes stars that we've never considered. Their screens glowed with silent, incomplete possibilities. They examined the backward star again, its brightness stable, its spectrum calm, its life proceeding peacefully. Nothing about it suggested distress or mutation. It functioned like any star burning hydrogen, emitting light, wrinkling space-time, except for the way it turned. Its rotation wasn't a mistake. It was an identity, a different kind of identity. Most stars are shaped by local physics. This star was shaped by history, by chance, by an encounter with a dark pair drifting through silence. Maybe that's what makes it different. the younger researcher said softly. It didn't evolve from physics alone. It evolved from circumstance. A circumstantial star, born not only from collapse, but from coincidence. Its properties were not defects, they were testimonies. The older scientist added, if we imagine stellar evolution as a straight path, then this star is the branch we forgot to draw. A branch where stars incorporate external motion, where they inherit rhythms, where gravitational memory shapes life cycles. They simulated the star's future using this new perspective. Most backward rotating stars eventually destabilize if their core and outer layers remain misaligned. But this star had already balanced, already settled, already smoothed. Look at that, someone murmured. The inversion didn't damage it. It strengthened its stability. Indeed, the model showed a surprising truth. The borrowed rotation had produced a slightly more efficient angular momentum distribution, less turbulence, less internal stress, more stable fusion, a longer lifespan. The backward star was not damaged, it was improved. The younger researcher stared. It's not abnormal, it's optimized. The room absorbed that idea like breath. A star shaped by history that ended up better off than if it had never been touched. This star, the older scientist said quietly, might represent a new evolutionary niche. Not evolution the way biology uses the word, but evolution in the slow, cosmic sense, where systems adapt to external influences, where interactions shape outcomes, where accidents become traits. A star that gained a new rotation because space decided to pass a shadow through its cradle. They examined its magnetic structure again. The echo was still there, steady, steady, steady. Like the metronome of a forgotten song, not a flaw, a rhythm, a second signature layered under the first. Could it have consequences for its internal convection? The younger researcher asked. They modeled it. The answer brought a hush. The magnetic echo softened convection cells, making them more uniform, limiting chaotic flares, reducing magnetic storms. The star was calmer than its peers, a tranquil star, a star soothed by a memory. And then someone whispered the idea the entire room had been circling. What if this is what happens when a forming star interacts with dark matter directly? The older scientist didn't breathe for a moment. Dark matter never interacts with baryonic matter except through gravity. But what if that alone was enough? If the presence of a dark companion, its gravitational curvature, its structured mass, could alter the cradle of a star? What if dark matter, he murmured, occasionally touches the lives of stars, and those stars become different? A dark matter-influenced class, a stellar category shaped by invisible wanderers, not exotic stars, not mutated, not scarred, simply different. Aligned to a history the visible universe did not record. The backward-spinning star was perhaps the cleanest example, the one with the clearest signature, but not the only one. How many others had been touched? How many carried memories too subtle to detect? How many stars lived entire lives shaped not just by gravity, light, and collapse, but by encounters with shadows? The researchers felt the question settle into them. What if the galaxy has always had two kinds of stars? Those shaped solely by their own collapse, and those shaped by encounters with the unseen. Stars of physics, stars of history. And this star, this patient, backward-turning thing belonged to the second kind. A different kind of star. A star with a memory. A star with a past. A star whose identity was written by a visitor that left no light behind. The older scientist whispered one last thought, barely audible over the soft hum of the computers. Maybe stars have always remembered the dark. We just never learned how to listen. A slow turn in the dark continued on the screen, steady, calm, perfectly balanced, the quiet revolution of a star that had been shaped gently, delicately, by the invisible hand of a traveler that no longer existed. They found themselves circling back almost without noticing to the earliest thought they had spoken on the very first night of this investigation. A sentence that felt poetic then, speculative, almost careless in its boldness. No object in the universe turns against its own beginning unless it carries a memory from the moment it was made. Back then, it was nothing more than a fragile hypothesis, a way of giving shape to the unease they felt staring at a backward spinning star. But now, with data spread across every screen, with maps of warped space and wakes of vanished travelers, with chemistry that carried fingerprints and magnetic echoes that sang old songs, the sentence no longer felt poetic, it felt inevitable. It had become the truth the evidence kept pointing toward. The younger researcher read the rotation profile again. Those layered curves, once abstract, now felt like a story unfolding line by line. It really is memory, she whispered. Motion as memory, the older scientist nodded slowly. A remembered moment, a remembered contact. That's what shaped it. And the star, turning backward with perfect serenity, seemed to confirm it each time it completed another slow revolution. They began analyzing the star's rotation not as a single measurement, but as a pattern across its entire lifespan. With the reconstruction tools, they plotted every segment of its spin, from its earliest turbulent days to its eventual smoothing, then to the long period where it surrendered to the deeper rotation. You can see the conflict, the younger researcher murmured, tracing the curve with her finger. The outer layers, fighting to maintain their inherited direction, and the core, quieter, slower, insisting on the memory instead. And eventually, the older scientist added, the star chooses the memory over the physics. Chooses. It was a strange word to apply to a star, as if it had agency, as if it could decide. Of course, it couldn't. But physics, when bent by history, behaves almost like intention. The researchers zoomed in on the transitional era, when the star's surface first began drifting toward the core's rhythm. The shift wasn't violent, nor was it uniform. It was gradual, like erosion. Layer by layer, the old rotation gave way. Not because the old rotation was wrong, but because the new one held deeper truth. A truth seeded by the encounter. It remembered the tilt better than it remembered its own birth, someone said. And that was when the room grew very quiet. Because the realization forming between them was larger than the star, larger than its mystery, larger than any gravitational wake or magnetic echo. They weren't just studying a single star's memory. They were studying the universe's ability to remember, not through light, not through radiation, through motion, through the way matter continues to turn long after the forces that shaped it have disappeared. What if memory, the older scientist whispered, is a physical property of the universe, not just a biological one, not just a concept, a physical fact? The younger researcher looked up, eyes wide. You mean everything that's ever touched anything leaves a memory behind? Yes, he said softly. In spins, in tilts, in curvatures, in quiet anomalies, in tiny things we overlook because they don't glow. The backward star had simply given them a cleaner record, a clearer example, a place where history and physics intertwined so gracefully the result looked impossible. They examined the chemistry again. The scars were faint but unmistakable, scars that didn't belong to fusion or convection or age, but to a single moment of disturbance long before the star's first light, a memory of something that passed through. They examined the magnetic echo again. The lower tone pulsed like the heartbeat of a ghost, echoing the orbital rhythm of the traveler that once brushed the cloud. A memory of something that moved. They examined the dust, twin channels, parted but healed, curved exactly like the path of the binary. A memory of something that parted matter like water. They looked at the region's gravitational shape, tilted, subtly, persistently. A memory of a presence that no longer existed. Across every data set, across every domain, magnetism, chemistry, rotation, dust, curvature. The same story repeated. Memory is written into matter. Memory is written into motion. The star wasn't abnormal. It was honest. It had preserved what happened to it, because the universe itself preserves the shapes of its own events. The younger researcher stared at the gravitational map at the arc, the bend, the faint pucker in space, where the traveler once drifted. It's like the fabric itself was creased, she said, and the crease never fully smoothed out. A crease in space-time, a wrinkle left by something invisible, and the star was born along that crease. No wonder it turned differently. Stars born in twisted space inherit the twist. Stars born in curved space inherit the curve. Stars born in passing tides inherit the tide. This one inherited the memory of a dark traveler. The older scientist continued, softer now. Maybe that's what stars are, repositories of the universe's most ancient events. The idea deepened, like a shadow stretching across the floor. Stars as memory keepers, their rotations as timelines, their anomalies as pages in a history no one knew how to read until now. The backward star wasn't an outlier. It was an archive, a single data point. In a forgotten ledger, the universe has been writing since the first clouds collapsed under gravity. The researchers began listing the implications. If stars can inherit motion from passing objects, then rotational anomalies across the galaxy could be records of ancient encounters. If chemical scars can be pushed upward by external tidal effects, then stellar chemistry could reveal entire genealogies of interactions. If magnetic echoes can preserve the rhythms of vanished systems, then stars might hold the signatures of dark matter structures we cannot see. If dust channels remain long after objects pass through, then every disk might be a fossilized footprint. And if space remembers curvature, the younger researcher whispered, then maybe memory is the fourth dimension's texture. She looked back at the backward star, still rotating steadily, faithfully, quietly, carrying its inherited direction through time. And then the thesis returned, not as a hypothesis this time, but as a law that had revealed itself late, gently, like a truth too patient to be noticed earlier. No object turns against its beginning unless its beginning was changed by something that never stopped turning. A slow turn in the dark, a memory passed on, a history carried inside a star. The older scientist finally spoke the words they all felt. This star is not defying its beginning. Its beginning was rewritten. And now, millions of years later, the star performs that rewritten story with every quiet rotation, as if honoring the moment that shaped it, not resisting it, not correcting it, following it. The thesis, once whispered, now echoed across everything they had learned. Memory is not an idea. Memory is motion. Memory is curvature. Memory is direction. And the universe keeps it everywhere, hidden in plain sight, waiting for someone to notice. They worked in silence for a long time. After that, not because there was nothing left to say, but because every new realization changed the weight of the air around them. The backward spinning star had become more than an object. It had become a mirror, reflecting not itself, but the structure of the universe it came from. The younger researcher finally broke the quiet. I keep thinking about how memory works in living things, she murmured. Not as photographs, but as patterns, behaviors, tendencies. Another added softly. And how those patterns persist even after the moment that shaped them is gone. They weren't trying to force an analogy. The analogy had forced itself. The star behaved like a being that had once been touched and never let go of the direction imparted to it. Not trauma, not damage, but a quiet, formative influence, a shaping. It made them wonder if they had misunderstood the fundamental difference between alive and not alive. Perhaps the distinction was less about consciousness and more about the capacity to remember. If memory required a nervous system, stars should not have memories. But if memory was simply the preservation of influence, then the entire cosmos was remembering itself in countless small ways. The older scientist leaned forward. "Maybe we've been looking for intelligence in the wrong places," he said. "We expect signals, languages, communication. We never considered that the universe might write its stories in motion alone. Motion as narrative, direction as testimony, rotation as remembrance." The younger researcher stared at the star's profile, glowing on the screen. "It isn't telling us how it feels," she whispered. "It's telling us what happened to it, and what happened to everything around it," someone added. "Space remembers, dust remembers, stars remember, just not in ways we ever tried to read." They began examining other anomalies across stellar catalogs. Small ones, easily dismissed, rotational offsets, tiny chemical mismatches, strange magnetic harmonics. Most had always been explained away as noise, instrumental drift, uncertain calibration, random variation. But what if noise was simply memory too complex to decode? What if the universe wasn't messy, just expressive? What if the galaxy is full of quiet stories, the younger researcher said, and we've spent a century trying to clean them up as errors? She highlighted a faint rotational irregularity in a star light years away. Not enough to be suspicious, just enough to hint, enough to suggest the possibility of another encounter, maybe less dramatic, maybe incomplete, but still there. We dismiss these things because we assume stars should be simple, but they are not simple. They are ancient, and touched by countless forces in their infancy. Perhaps too many stars carried such traces for astronomers to notice the pattern earlier. "Maybe," the older scientist said quietly, "the universe has been whispering this all along. A slow turn in the dark, hidden inside thousands of stars, waiting for one clean example that refused to hide what happened to it." The backward star was not a cosmic accident. It was a clean page, a well-preserved memory, a rare case where every clue survived well enough to be read, a perfect witness. They looked at the region's gravitational map again, the corridor, the pivot point, the faint second wake from the other dark traveler. Even the galaxy's architecture carried scars of movement, even the spiral arms. Those vast glowing rivers were shaped by ancient passages of matter most telescopes would never see. The younger researcher asked a question so soft it nearly dissolved into the hum of the room. What if memory is not something that happens inside the universe, but what the universe is? A stillness followed, not heavy, not frightened, just the stillness that happens when a truth brushes past the mind before it chooses to settle. The older scientist leaned back. "Space curves when touched," he said. "Stars change when brushed. Dust moves when nudged. Patterns persist. Influence persists. That is memory." They weren't redefining physics. They were discovering its emotional equivalent. Memory as curvature, memory as rotation, memory as the persistence of effect after its cause has vanished. A whisper of a whisper, held indefinitely. A slow turn in the dark. "And maybe," someone said, "that means everything we see today is shaped by things long gone." The thought was vast, uncomfortably vast. If true, galaxies were tapestries woven from forgotten events, knotted fields, ancient drifts, encounters that left no light but left marks. Marks like the reversed spin of a single, quiet star. It made them wonder if the past was never truly gone, not in a philosophical sense, but in a measurable, scientific way. Light carries the past forward, but motion carries it deeper. Chemical composition, magnetic echo, rotational direction, all of these were long shadows cast by moments that ended millions of years ago. "We think of time as something that flows," the younger scientist murmured. "But maybe time is something that folds around events, folds around encounters, and whatever folds deepest stays." The room felt wrapped in that idea. If time folds, then stars are creases, places where history catches and refuses to smooth out. Creases that glow, creases that burn, creases that last for billions of years. They looked again at the backward star, its gentle, unwavering spin, turning the way space had asked it to turn on the night it formed. What if the star wasn't resisting its origin? What if the origin itself had changed shape, and the star simply honored that shape as truth? The younger researcher whispered, "It isn't a mistake. It's a memory of the correct direction for the universe it was born into." And suddenly, everything made sense. The star did not carry a contradiction. It carried a reference, a coordinate, a record of the geometry that once existed around its cradle, geometry carved by a traveler whose own path had long dissolved into emptiness. Without meaning to, the star had preserved the orientation of a vanished system, and that made it more than a star. It was a compass needle pointing toward a moment no longer present, a needle still turning with the same slow rhythm that once brushed its forming core. A slow turn in the dark, not as anomaly, but as testimony. The team realized then that they were not reading a star's life. They were reading the life of the thing that touched it. Stars were not only born of collapse, they were born of encounters. What touched them shaped them. What shaped them remained in them. And in those quiet signatures, the universe had always been keeping its own diary. Not with ink, not with atoms, with motion. As the room dimmed into the late hours, the researchers found themselves speaking less and listening more, not to each other, but to the quiet rhythm unfolding in the data before them. A star turning backward, a memory folded into rotation, a history stored not in matter but in motion. They had begun this journey, searching for an explanation. But now they were no longer certain explanation was the right word. What they had discovered was not simply the cause of an anomaly. It was something gentler, deeper, as if they had brushed against the edge of a truth that had always been there, waiting for someone to slow down enough to hear it. The younger researcher leaned back in her chair. "When you think about it," she whispered, "everything we've learned, it feels less like science and more like listening." The older scientist nodded slowly. Maybe that's all science ever was. Listening to how the universe answers when something touches it. They stared again at the model of the star's current rotation, smooth, quiet, backward, like a pendulum swinging in a direction time itself had forgotten to sweep clean. If memory is motion, then time becomes less of a river and more of a lake, still in places, rippling only where stones were once dropped. The backward spinning star was one such ripple, still widening across millions of years, long after the hand that cast the stone wandered into darkness. The younger researcher traced the curve on the screen with her fingertip. "It feels lonely," she said softly. But the older scientist shook his head. "No, it feels loyal." There was a quiet gratitude in that word. Loyal. The star was loyal to the moment that shaped it, not out of choice, but out of the simple fact that matter carries what touches it. "We always imagine stars as isolated," someone murmured. "Born alone, living alone, dying alone." But that was never true. Stars are born in crowds, collapsing clouds, colliding flows of dust and gas. And sometimes, rarely, beautifully, they are born in the passing shadow of something that does not shine. And when that happens, they remember. They remember more faithfully than creatures with brains, more patiently than planets with orbits, more clearly than galaxies that swirl and forget the shapes that first wound them. Because nothing in the universe resists forgetting less than a star's rotation. Rotation is pure memory, not metaphor, fact. "Maybe," the younger researcher whispered, "we've been looking at memory wrong. Maybe memory isn't something stored inside living things. Maybe it's something stored inside everything." The room quieted again. The idea was simple, almost unbearably gentle. The universe remembers not through intention, not through thought, but through persistence. A curved line in a gravitational map, a slight chemical mismatch, a reversed spin, a magnetic echo that refuses to fade. These were all forms of memory traces, of events too quiet for sound, too old for light, too delicate for textbooks. The backward spinning star became less of a mystery and more of a conversation partner, speaking in rotations, answering questions no one knew to ask. "What if every strange star is a story?" someone said. "And every missing object," another added, "is simply a chapter we haven't reached yet." The thought sat with them like a soft weight. So much of astrophysics is built on the idea of causality. Force, energy, tempers of plasma, collisions of giants. But what if the deepest truths of the universe were not explosive or violent or bright? What if they were quiet, brief, almost gentle, a tilt in a core, a soft twist in dust, a whisper of plasma trailing a remnant, a gravitational crease left in space? None of these things roar, none of them burn, none of them shine, and yet here was a star turning backward millions of years later, as if carrying a small lantern for something long gone. A slow turn in the dark, not as rebellion, not as anomaly, but as remembrance. The younger researcher looked at the star one more time, its profile glowing softly in blues and golds. "It's strange," she said. "We've spent all this time trying to understand the star, but it feels like the star is the one trying to understand us." No one disagreed. There was a sense now that the star wasn't simply being observed, it was being heard. Not literally, but in the way a memory is heard when someone finally learns to ask the right question. One scientist finally spoke what they had all been feeling. "Maybe this is the closest thing the universe has to empathy. Not emotion, but recognition, acknowledgement, a willingness to carry the marks of what passed through it. Stars don't understand, but they do not forget, and maybe that is its own kind of tenderness." Outside, the night sky remained vast and silent, but inside the room, the backward star held all the silence, in a shape they could finally read. They dimmed the monitors for a moment, wanting to see what the star looked like without color maps, without enhancement, without labels, just a point of light, small, still, patient. A single shimmer in an impossibly dark canvas, a shimmer turning backward, because once, long ago, something passed through its cradle and left a handprint no cosmic wind could erase. A memory so old and yet so clear that even now, as the universe aged and expanded, the star continued to carry it like a secret, a slow turn in the dark, and a quiet promise that nothing the universe touches is ever truly gone. They let the room grow dimmer, not because the work was done, but because the brightness of the screens suddenly felt too sharp for the softness of what they had uncovered. Some truths are easier to hold in the half-light, where edges loosen and the mind becomes quiet enough to hear what hides beneath sound. In that dimness, the backward spinning star no longer felt like data. It felt like presence, a small, steady glow sitting at the edge of a long-forgotten corridor, still turning in perfect fidelity to the moment that shaped it. Someone whispered, almost to themselves, "It's strange how something so small can feel like the center of everything. Not the physical center, not the gravitational center, but the emotional one, the conceptual one, the crossroads where the universe's quiet rules reveal themselves not through equations, but through attention." They zoomed into the star's rotation profile one last time. Soft curves, gentle transitions, an axis leaning in the wrong direction, yet leaning with such calm inevitability that it no longer looked wrong at all. It looked true. Whether that truth belonged to physics, or to history, or to something older than both, none of them could say. But the truth was there, turning with each rotation, as constant as breath. The younger researcher rested her head against her chair, watching the quiet spin on the screen. "Do you think," she whispered, "that somewhere the traveler remembers too?" The question rested in the air like dust suspended in a beam of late light. The older scientist took a long time before answering. "Objects like that, they don't remember the way stars do. They leave memory behind. They don't carry it. A pause, a slow inhale. But maybe, he added gently, that's why stars exist, to hold the memories of things that don't stay. The thought settled inside the room like snowfall, soft, fine, every flake the same shape as silence. Maybe stars were the universe's journals, not deliberate ones, not crafted ones, but journals nonetheless, glowing scribes that preserved every touch, every tide, every passing, every whisper of something that slipped through the dark. The star before them had simply kept its page unusually clean, its rotation soft as a clock. Forgetting the direction of time and choosing the direction of memory instead became the center of their attention once more. The quiet backward sweep, the calm arc, the effortless glide of layers that had once fought each other and then surrendered to a deeper rhythm. There was something peaceful about it, unexpectedly peaceful, as if the star had long ago accepted the shape of its past and grown into it. A star born wrong, someone had said on the first night. But now that phrase felt childish, as if they had mistaken difference for error, mystery for malfunction. There was no wrong here, only inheritance, only the graceful persistence of what once brushed the world into being. The younger researcher let her eyes soften. It looked so quiet. Quiet things usually carry the deepest stories, the older scientist said. And the star did carry something deep, deeper than its light, deeper than its fusion, deeper even than the gravity that held it together. It carried shape, it carried direction, it carried the memory of something that had no light of its own. A traveler that drifted, silent as an abandoned orbit, through the cradle of its birth, now lost, now hidden, now gone into a region of the galaxy where darkness was deeper than night. But in the star, the trace remained, not a scar, not a break, a simple, patient turn in the opposite direction, a slow turn in the dark. Someone dimmed the last overhead light, not to sleep, but to listen better. In the quiet, it became possible to imagine the forming cloud, soft, cold, waiting, and the traveler's approach, weightless yet heavy, lightless yet shaping its presence, bending space-time like a hand brushing fabric, a moment that space kept, a moment the star performed, a memory so subtle it had taken millions of years and the right eyes to be noticed at all. Perhaps there were countless such moments across the galaxy, untold meetings between matter and shadow, between presence and absence, between the bright and the invisible. Moments shaping stars that no one had ever looked at closely enough. Moments forming constellations with stories buried in their spins. Moments never lost, just unrecognized. One researcher closed their eyes. If all of this is memory, they whispered, then looking at the night sky is like reading a diary the universe forgot it was writing. No one spoke after that. The thought was too large, too fragile, too beautiful to touch. They simply watched the star for a long time, its gentle backward rotation, its soft magnetic hum, its fading chemical echoes like listening to a lullaby sung in a language older than sound. Outside, the night moved slowly across the world, unaware of the quiet revelation unfolding within a small, dim room. Inside, the starlight on their screens remained still, faithful, calm. They didn't need further analysis. Not now. The facts were all there. The physics was all there. The mystery was all there. And the meaning, the quiet, aching meaning, sat in the center of it like a lantern that refused to go out. This star was not strange. It was honest. It was not broken. It was marked. It was not anomalous. It was remembering. And its memory did not ask for understanding or classification or discovery. It asked only to be heard. The younger researcher whispered, barely audible, "What else is out there?" turning quietly in ways we haven't learned to listen to yet. And instead of answering, the older scientist simply exhaled a long, thoughtful breath, the kind that acknowledges the enormity of everything and the smallness of being the ones who witness it. The monitors cast a faint glow over them, a light soft enough to feel like night, warm enough to feel like presence. The star turned again and again, slowly, backward, faithfully, carrying its borrowed direction through the dark with the patience of something that knows time cannot erase what truly shapes us. The younger researcher closed her eyes. "Do you think," she whispered, "if anyone else ever looks close enough, they'll hear the same story?" The older scientist smiled gently. "If they're quiet enough," he said, "they will." Silence settled, not empty, but full. A stillness so complete it seemed, made of the same substance as starlight. And somewhere far away, beyond every catalog and map, the traveler continued drifting through the black, carrying its own quiet momentum, perhaps brushing new clouds, perhaps leaving new memories, perhaps shaping stars no one would ever find. But here, in this room, only one thing mattered: a single star, still turning backward, like a whisper carrying itself through the dark. A slow turn in the night, a memory in motion, a story left glowing long after all its characters have gone. Close your eyes now. The universe is still turning. And yet, somewhere just beyond that thought, there was something else waiting. Not another discovery, not another equation, just a clearer way of seeing what had always been there. Because once you understand that a star can carry memory, you cannot look at the sky the same way again. The next days in the observatory felt different, quieter, somehow softer around the edges. The same instruments hummed, the same screens flickered, the same graphs crawled across the same displays. But each point, each line, each wobble in the data no longer looked like a number. It looked like the outline of some old event, still echoing in a language they were only just beginning to learn. The backward spinning star remained at the center of their work, but now it wasn't the only thing they watched. They began to comb through other stars with the same care: slight rotational slants, soft magnetic delays, chemical traces that didn't quite match the standard models. Not because they needed to prove themselves right, but because they couldn't shake the feeling that this one star was simply the first page in a much larger archive. Some stars showed nothing, perfectly ordinary. Spinning forward, chemistry smooth, magnetism forgetful. But some had little glitches, nothing large enough to publish on its own, just soft, persistent deviations. A lag that refused to drift, a helium line a touch too strong, a dust lane split ever so slightly off-center. Little hints that perhaps they too were formed in the wake of something unseen. The older scientist began to speak about them differently. He no longer called them errors, he called them traces. "Look here," he'd say, pointing not to the peak of a graph, but to the slight bruise of asymmetry hidden beneath it. Something brushed past this one too. It just didn't leave as clean a signature. The younger researcher watched patterns begin to assemble in the noise, like constellations emerging not from stars themselves, but from the ways their spins leaned against expectation. One star with a barely off-axis rotation, another with nitrogen faintly elevated, another with a magnetic cycle that whispered of a second, weaker rhythm underneath. Each alone could be dismissed. Together, they suggested a quiet, diffuse network of forgotten encounters. Not all as dramatic as the dark binary passing through a cradle, but still, moments where the invisible pressed its shape into the visible. They started cataloging them, not as a new class, not yet, but as a new layer. A layer of stars, marked not by what they are, but by what they've met. In one corner of the sky, a star rotated just a little too slowly for its temperature. In another, a dust ring bore a faint trough with no obvious cause. In another, the surface elements refused to match the age implied by its light. Tiny things, barely anything at all. But once you've heard one whisper, you can't help but listen for others. And slowly, a picture formed. The galaxy is not just a place where stars are born and die in isolation. It is a place where some of them are brushed, tilted, stirred, and quietly rewritten by encounters with things that never shine. Not often, not dramatically, but enough that here and there, one star turns a little different from the rest and keeps turning that way for billions of years. They returned again and again to the backward star, because it was the clearest case, the one where everything aligned: the dust, the chemistry, the gravity, the echo, the memory. It was their reference point, their origin of coordinates for this new way of listening. Outside the observatory, the night sky remained the same as it had always been to the naked eye: a scatter of distant lights, each point sharp, each point silent. But inside, those same points began to look like something else: tiny knots in a vast tapestry of motion, each one anchored to an event that might long since have vanished from sight. The younger researcher found herself lingering by the window between runs, looking up not to admire the stars, but to imagine the invisible scaffolding underneath them. Dark. Travelers weaving their way through the spiral arms, remnants trailing weak plasma like fading breath, clouds collapsing along creased lines in space, stars forming in their shadows, inheriting tiny fragments of their motion. No stories, no intent, no design, just memory. It made the universe feel less empty, somehow, not because there were more things in it, but because the things that had already existed were more connected than they first appeared. What we're seeing, the older scientist said one evening, eyes on the backward star, is that nothing really happens alone, not even the birth of a star. He said it softly, almost apologetically, as if he were correcting an old belief he'd carried for most of his life. They had always thought of stellar formation as a local event. A cloud collapses, gravity works, the star ignites. Neat, self-contained, complete. But now they could see the threads that tied even that simple story to a wider, older one. A dark binary wandering through space, a subtle curve in gravity, a faint wind of plasma, a core that bends, a memory that stays. A star whose entire future takes its shape from a moment that lasted only an instant on the scale of the cosmos. A slow turn in the dark, born from something that barely stayed long enough to leave a trace. The younger researcher thought about time, how human time is measured in days and years, in clocks and schedules and seasons, how cosmic time is measured in orbits and collapses and burns, and how memory, at its simplest, is just the physical refusal of something to entirely let go of what has happened to it. She realized that, in a way, even she was not so different from the star. Her life, its tilt, its choices, its quiet rituals, had been shaped by encounters that came and went in moments. A word spoken once, a look that lasted a second, a silence over a dinner table. Things so short they didn't even count as events in the chronology of a day. Yet they left directions inside her that she kept following long after the moment itself was gone, just like the star. A forming core touched by a passing shadow, turning backward millions of years later for no other reason than that it remembers. It made the universe feel strangely close, not because it was kind, but because it was consistent. The same rules that let a star keep its memory were at work in everything else. Planets remember the pushes that altered their orbits. Galaxies remember the mergers that twisted their arms. Black holes remember the mass that fell in. And somewhere, at the quiet end of a forgotten corridor, a solitary star remembers the night a traveler with no light passed through its cradle and left. They would write papers, of course. They would publish models, propose terminology, argue about classification. Other scientists would question the data, test the conclusions, search for alternative explanations. That was how knowledge moved forward. But none of that would change what the star actually was: a point of light spinning the wrong way, and in doing so, pointing at something else entirely. A signpost, a marker, a place where the visible universe briefly and quietly intersected with the invisible one. As the night grew later and the observatory grew quieter, the researchers began to drift away one by one, pulled back toward their own small gravities. homes, beds, the simple need to rest. The data would still be there in the morning. The star would still be turning. The galaxy would still be curling its arms around a center that might never be completely understood. The younger researcher was the last to stand. She looked once more at the screen, at that soft, backward sweep, calm as a slow inhale. "Thank you," she whispered, to no one in particular. To the star, to the traveler, to the cold cloud that once bent in the dark, to the quiet mechanisms of gravity and plasma and time that allowed such a small, delicate memory to survive for so long. The star didn't answer, it only turned, but in that turn was everything it had to say. When she stepped outside, the sky felt different again. Not less vast, not less overwhelming, but somehow more intimate. Somewhere up there was the star they had been watching. To the naked eye, it was indistinguishable from millions of others. Just another point, another distant glimmer, another anonymous light. Only she knew that its light moved in a way slightly out of step with the rest. Only she knew that its rotation was a story about something that no longer existed. Only she knew that inside that small glow was an entire history of a passing shadow written into motion. It made the night feel like a page, not blank, not finished, but still being written. And though she couldn't hear it with her ears, she knew somewhere behind the silence there was a rhythm, a slow turn in the dark, a quiet backward spin, a memory that had learned how to shine. If you find yourself under a night sky someday, looking up at all those distant, patient lights, you might think of this, that somewhere among them there is a star turning the wrong way, for reasons that have nothing to do with error and everything to do with memory, and that perhaps the same is true for you. You do not move the way you do by accident. You are turning around the shapes of every unseen thing that has ever brushed your life, and still you glow. Let that thought be enough tonight. Let the universe keep its deeper secrets a little longer. Let the stars continue turning their quiet histories through the dark. Let the travelers wander where no map can follow. You don't need to know where every shadow goes to rest under their faint light. You just need to know this. Far away, a star that should have forgotten never did. And, closer than you think, a mind that should have fallen asleep by now is still listening. It's all right to let go, now. The star will keep turning. The memory will keep moving. The universe will keep writing its stories in motions too slow to disturb your dreams. You can close your eyes. The sky will still be there when you open them again. And somewhere, in a part of the galaxy no one will ever visit, a quiet star will still be turning backward softly, faithfully, like a heartbeat in the dark that never needed a name. If you're kind enough to stay in this small corner of the night a little longer, whispers of the universe will be here, listening with you. But for now, breathe. Let the questions drift a little further away. Let the answers follow them. The universe is still turning. You don't have to.